right, so we talked about the deep dive yesterday as the final session in session 2. Session 3 today is going to be talking about the deepest capabilities, or what I'll call the most advanced capabilities that we have. That's connecting SolidWorks to the 3D Experience platform. So the three major topics that we're going to discuss today is cloud-based sculpting, which is really how the chassis and the body style of this came together. Then we're going to talk about cloud data management, which is probably one of the biggest topics in today's mind. It's really just about what do I do if I don't want to go to PDM? What do I do if I don't want to use Windows Explorer? In fact, you shouldn't be using Windows Explorer, especially on an assembly this size. And then simulation without limits, just being able to actually do all of your calculations on the cloud. The days of having these workstations that you must have that have to have this crazy amount of performance, those days are quickly starting to go. There are easier ways to do cloud computing and get the answer a lot faster. You cannot build a machine more cost effectively than what you can get that performance on the cloud from. So we're going to talk a little bit about that as well. So our first section today we're going to talk about is cloud-based sculpting. So cloud-based sculpting, again, is how we actually got to the chassis shape that you see here. And this is a pretty complex shape. This is a pretty complex problem. So we're actually going to go kind of through the day in the life of some of the users from U-Boat-Works to kind of see how they collaborated to get all of the machines inside of that chassis packaged around the body panels, and how the body kind of got shaped around all of the other components, and how we got it to look attractive yet still functional. So let's talk a little bit. Innovation is the essence of product design, and it could be your company's biggest competitive advantage. This is really how you win business if you're in this space. It requires creativity, agility, and the ability to churn through concepts as quickly as possible. Now, I'm going to call this iterative design. This is not rework. Rework is when you go through the process, you find mistakes, you have to go back and you have to redo a lot of your work. We're talking iterative design. Step 1, step 2, step 3, taking the concept, getting it to work, making it better, one step at a time. Parametric surface modeling delivers on creativity and agility, but the process is time consuming. It usually requires a rare level of surfacing expertise, and to be successful with typical surfacing methods, you have to plan that model really well. If anyone's ever tried to draw an automobile or a fender or a hood inside of SolidWorks, you know what I mean by this. You have to plan, you have to drop a sketch down, you have to trace along that sketch, you have to add a million reference features, and you have to really think about every single surface and trim that you do to get to this shape with traditional surface methodology. That's where that planning comes in. And then you have to be pretty good at it just to get things to show up the way you want them to. But subdivisional modeling, it's spontaneous. It requires minutes of training, and the changes are visualized in real time. On the platform, it's available on any device with an internet connection, and it's also compatible with your existing SolidWorks workflows. So realistically, this is a tool that every product designer needs in their toolbox. Let's discuss the impact here on the process. Everyone that is using SolidWorks and modeling complex surfaces can probably benefit from cloud sculpting. This process is used in conjunction with SolidWorks, not a replacement for SolidWorks. This is used to create more than just a concept. So we're going to talk about the conceptualization in 3D, the collaboration with SolidWorks, and the fact that this is not just a concept blob. this can actually be turned into a feature that you drop into SolidWorks and work on. So Dan, the industrial designer, and Don, the mechanical engineer, are spearheading the concept design of the Nemo submersible. So we're going to kind of go in role and we're going to play along with them and see how they got this design to come together. So let's jump in on Dan in 3D Sculptor as he takes on the initial body concept. Every concept design has a unique starting point. In this case, progress has already been made on the underlying frame assembly. So we have a pre-existing assembly. This is from SolidWorks. You can see on the left there, that came in from SolidWorks. We're now inside of 3D Sculptor. They're readily available for him to reference from SolidWorks. We bring them into Sculptor, right? We're just opening the file, just like you would open any other file. And right in the browser, he can see the concept. He can draw on the screen through a sketch, place that in. That could also come in from SolidWorks. Other concepts might start with just a hand sketch, but in X-Shape, this is not traditional for the cloud apps, but it is traditional for SolidWorks users. SolidWorks users usually start with a sketch and they start drawing on top. You can do that if you want to, but it's really not necessary. We can just pick a shape, drop it in over that frame, whether you have a sketch or not, and you can start transferring your vision onto this paper. Subdivisional modeling gets its name from the loops and edges and vertices that surround the shape. The more of those there are, the more control you get. But it's also like a spline in SolidWorks. It's better to start with less than more. So you'll see, as we're manipulating this shape, the main user input is the on-screen manipulator called the robot, and the shape is always edited with respect to its position. So Dan can move it to the left edge to keep that side stationary. Pushing and pulling the geometry is the main interaction in sub-D modeling. The robot can be used to translate, rotate, and scale the shape. The other half of the battle is really just selecting geometry. In X-Shape, there's plenty of shortcuts. For example, he can use Shift Select, grab two faces, and then he can get the entire loop between them. And then he can utilize the tools in the robot to transform the shape. By default, all faces have a C2 level of curvature continuity, which is ideal for any industrial product design. However, select edges in this case could be creased at any time to enhance the style. So we've got this slider up here, and Dan can adjust the smoothness factor applied to the crease. Now we can get a different shape on the edges. Once he's done, and X-Shape just kind of runs in a browser, so he's making all these changes on the fly, all real time. Once he's done with that shape, you can really kind of play around with that geometry. And we have actually found that this is more fun on a tablet because you can swipe and use a pen and you can use your finger on the screen, and it just kind of makes it pretty interactive. You can switch to other orthogonal views, and it makes it easy to size, shape, and position the first body. You saw how he kind of clicked that and he drug it over to the side to kind of get it aligned in 3D space. And it's using a lot of the features that we're all familiar with. You saw how he clicked on a line there. He got it to align to an edge. He drew the edge first, said, align the shape to the edge. The thing snapped into there. The robot can also be repositioned onto an edge by itself if you need to, if you need really precise measurement control on some of these faces, which really kind of sets it apart from a lot of the other methods that are out there because you don't get that really precise control in most of the other sub-D modelers that are out there. So precision can be applied to the length of this translation too, because there is a part of an assembly that sits back there. So that needs to be, fairly accurate as some of the other things don't necessarily need to be. You can see how when he's clicking around, he gets that on-screen ruler that helps you snap to the correct dimension. Now that one side is done, he's ready to move on to the other side. You saw how he used the extrude command. He just clicked on the face and hit extrude. Pretty self-explanatory for some folks. If you're used to using SolidWorks, that's very common workflow, just doing a simple boss extrude. Now, Once one side is done, he gets the shape kind of sculpted the way he needs to, he can move on to the other side. So we can, use symmetry and kind of flip this to the other side. And after pulling and pushing, anything that you change along that center plane with symmetry active will change now on both sides. So now we can actually modify both sides of this at the same time. And so that option stays on. You're going to see again how he uses the alignment tool. You create a line, hit align by entities by line, and it'll snap that entity to that side. And that's where you get some more of that precise control. So now he's working on the hood, which is on top. And to ensure that it's perfectly flat, he can just use a typical sketch line, align to a point so that you can make sure that it's perfectly flat relative to that 155 dimension that he's got up there. And then you can move the endpoints and translate and scale the entities while snapping them to that orientation. Now that the general shape has kind of been roughed out, Dan can focus on a few finishing touches before sending his design out for review. We're going to add 2 horizontal loops into the midsection that make way for the hole that will travel through it. So you can see these pretty powerful features. If you were to try to surface this in SolidWorks, you would already be several hours into this, and we're actually just, about a minute and a half total through this one. And loops are a pretty common command. They're easily accessible from the context toolbar, a user interface feature that most SolidWorks users can appreciate. The vertical loop is going to provide a boundary for the hole in the back, as well as the scoop on the bottom as we go to create some inlets and ports for other geometry that's going to happen later on when you guys see the assembly stacked together. You can actually see a little bit of it in transparent mode there. But in minutes, Dan has pretty much enough detail to share his concept with the rest of the team. The sub-D modeling capabilities in X-Shape provide the fastest way to conceptualize in 3D. And considering the amount of information communicated by a single 3D model, it's arguably faster than sketching on paper, especially if you get that 3D detail, right? But what about SolidWorks? What happens when the reference frame assembly is modified? Let's check in with Don as he continues to make progress with SolidWorks Desktop connected to the 3D Experience platform. All of the Nemo design team's data on the cloud is accessible directly in the SolidWorks task pane. So we're in SolidWorks, we're using the 3D Experience panel pane over here just like you would in PDM. To ensure Don's changes aren't overridden by another collaborator, he can reserve the files he plans to modify. Searching through their entire database takes a few seconds, but he finds the components he's looking for quickly. Then all it takes to add them to his assembly is a simple drag and drop. After the propulsion and hatch assemblies are changed and brought in, he's ready to save his changes, which he's working on, the engineering side of things, right? Just like that, his modifications are securely stored to the cloud, accessible to anyone with proper permissions anywhere in the world. Curious about Dan's progress, he can perform another search for the body design. Once he locates it, that part file is called a physical product. So he drags this in, mates it into there with the center planes. And even though it was designed in X-shape, Don can drag it right into his SolidWorks assembly to do a quick visual check on how his recent additions might influence Dan's design. By activating a preview in 3D Play, Don can sketch some annotations to indicate the adjustments needed to account for the newly added components that he put into the assembly in SolidWorks. Then he can post them directly to their private design team community for Dan to see. Even though Don has some work to do still, it's not too soon for Dan to go in and modify some of his shape changes in X-shape. Don can continue working in SolidWorks, and since that X-shape geometry comes in as a flawless watertight solid, it's ready for extrusion, cut extrudes, and everything else that you would need to get that thing ready for the actual SolidWorks design. So you can split it, piece it together, part it out, add tabs, actually add the engineering side of things to this. So the 3D Experience platform unlocks many new capabilities and applications like X-shape, and they're all capable of collaborating with SolidWorks. The best part is they enable hybrid workflows, allowing you to stay in sync while working concurrently. Designing an X shape can go beyond the concept stage. Let's drop back in on Dan as he revises and refines the final body shape to the highest level of precision, more than a concept now. As Dan's working in X shape, he receives a notification from Don's post. By clicking on it, he's taken directly to the community where he can review the proposed changes and let Don know that he's going to start working on it. A quick refresh to the frame assembly, and all of Don's changes are now visible to Dan in X shape. And it's up to date with all the latest designs. Of course, the exact same assembly structure that exists in SolidWorks is visible in X shape. So Dan can start strategizing about the changes, how he's going to go about changing that shape that he created previously. To keep the design tree organized, Dan creates an ordered geometrical set to house his reference sketches. By converting the outer diameter of the hatch opening, for example, he'll have a clear view of the edge he'll need to blend the opening of the hood to. So he's tying a reference in now, very similar to how you would in SolidWorks. Rather than adding a loop of vertices surrounding the entire perimeter of the body, Dan can add a localized group of entities with the subdivide command. Now he can select the new loop of edges on the hood and the corresponding edge of the hatch, and magically, the Align to Curve command perfectly aligns Dan's X-shaped geometry to Don's SolidWorks assembly, now tied together. And just like the style splines in SolidWorks help to parametrically control splines, the cage view in X-shape reveals the underlying constraints driving the curved surfaces, making it apparent when edges are out of alignment. After selecting the vertices in sequence, Dan can easily align them to each other. The side view reveals that the front faces of the hood are also out of alignment, so once selected, they can be made coincident to each other from that context toolbar, just like mates in SolidWorks. To hone in the angle of the front faces, Dan can select the entities and reposition the robot to the pivot. If this was a face that required a specific draft angle, Dan could snap that onto the screen protractor to dial it in perfectly. To leave the coincident faces undisturbed, Dan can once again reposition the robot accordingly. So it's a very powerful little tool for sub-D modeling. Dragging the webbing of the robot will ensure his translations maintain the coplanar alignment of the faces. After a few more adjustments to the hood, Dan is ready to tackle the pathways on the side of the design for the thrusters. He'll prepare a set for each one, not just for organization, but also to sever their dependency on the order they exist within the design tree. Using the cylinder shape and automatically creasing each end will make it easy for Dan to locate the first pathway in relation to the vertical thruster. In a similar fashion, he duplicates the process of modeling the negative space required for the horizontal thruster. There are now three separate solid bodies that can be combined to form the final shape. And similar to SolidWorks, the combine feature has multiple options for Boolean operations. The subtraction looks good, but Dan also notices the intersection between the vertical and horizontal pathways is a little bit too high. To remedy this, Dan will need to lower the vertical pathway because each body was placed in a separate set, but he's still able to see the horizontal pathway even though it exists below the vertical pathway in the design tree. This allows him to predictably position the vertical pathway in relation to the horizontal pathway with no trial and error. He decides that that looks perfect. We can take one final look at the overall shape, and it appears that Dan's job is complete. Very, very powerful software, getting a lot of features over from SolidWorks to make it very user-friendly and very, very familiar. Jumping back into SolidWorks, the model has been updated And Don has made further progress on the parametric features. He's even split the body into multiple components using the master modeling technique. It won't be long before the project is completed. So Xshape provides an unlimited amount of design freedom and flexibility, but you can use it to design much more than a concept. When necessary, it's capable of precision fit for any downstream operation. So the sub-deep modeling environment is one that every product designer can benefit from. There's no installation required, almost no training is necessary. There's no faster way to model complex geometry like this out today. And there's certainly no reason really to not expand your design capabilities with this great new tool if you're doing a lot of industrial design. So now that we've talked about cloud-based sculpting, we're going to jump into cloud data management as our second session. Whether you work in a large organization or just a small team, no doubt you're concerned with strong uh, applications for storing, managing, and collaborating on your design data. You don't want to have everything local on your hard drive. You don't want to connect everything to just a Windows-based server. You need something that will safely store your data. And it's tricky, right? Because SOLIDWORKS parts, assemblies, and drawings and other supporting documents, they're all linked. We all know this. We've all saved over a part file, opened one and realized, oh crap, I saved over that. And now because you don't have a data management platform, you can't do a where use and figure out exactly how prevalent you've made that mistake. Consumer cloud storage apps don't really know how to handle that. So I'm talking about Dropbox. I'm talking about GrabCAD, right? Maybe the investment in SOLIDWORKS PDM and manage is also not right for you. But there is another way. When you connect SOLIDWORKS to the 3D Experience platform, cloud data management is really just a few clicks away. If you're used to using PDM, it actually works very similar to SOLIDWORKS PDM, just that it's on the cloud. So Eric the engineer and Debbie the designer are part of the team working on the Nemo submersible. They're on a tight deadline to finish up the hatch design on top of the submersible. Let's see how they're able to safely store their data, manage changes, and design concurrently without ever leaving their SOLIDWORKS environment. So this is all in SOLIDWORKS. Eric is going to put the finishing touches on the latch mount by inserting fasteners from SOLIDWORKS Toolbox. So he's going to do a quick check on the assembly drawing, and once he tabs back over to the assembly drawing, everything's up to date, and he's ready to save that to the cloud. So he'll navigate over to the right, find the 3D Experience button, then he's prompted to log in, and that is his secure connection to the cloud. So right there in that browser, basically turns into your browser if you don't want to use the browser itself. So right from the task pane, he sees the status of his work. These indicators show which components need to be saved. As for the hardware and other standard parts, SOLIDWORKS is configured to automatically catalog and release these items, so all users can access their shared libraries online. The Save dialog shows exactly which items require an update. He can also assign any item to a bookmark, such as a related drawing file. And out of a long list of components like this, bookmarks are a very convenient way to flag them for easy access. Only the new or changed items need to be uploaded to the cloud. This makes efficient use of the network bandwidth, but still ensures everything is up to date. As the leader of his team, he's able to release his own designs, small team. Easy to use lifecycle operations like this helps the team avoid accidental overwrites. Those permissions are very controllable. Switching over to his bookmark tab, he sets the related part assembly drawings to released. It's just 2 drawings for now, but as the detailing work continues, the bookmark will keep everything organized for quick access. That includes any other supporting documents like the PDF instruction sheet and the related SOLIDWORKS composer file. Most document types can be previewed interactively within the SOLIDWORKS task pane, and there's no need to launch external viewing apps, which means that you're doing all of this, again, right here in SOLIDWORKS. Eric has a backlog of finished designs that also need to be uploaded to the cloud. He can automate this with a batch save. He just selects his local design folders and assigns them to the appropriate cloud space. SOLIDWORKS takes care of the rest. So you go in here, you fire and forget. So safe and secure cloud storage of your SOLIDWORKS data, no reason not to use that, right? You can use this right away, right out of the box. There's virtually no setup to this. As the Nemo sub-design evolves, the team must respond to change orders quickly. Let's see how Debbie takes advantage of cloud data management to create a new revision to the latch hand wheel. Debbie logs into her session and sees a message from Eric requesting a change. A quick keyword search shows several results. So she goes in, she finds the right one. All the property data is there, as well as a comment thread. Eric wants a racing-inspired hand wheel. So she types in her reply, and then she's ready to get started. She takes the information from Eric's request and collaborates with him in a thread on the platform in order to change the design and head in the right direction. Once somewhat satisfied with the direction she's headed, she opens the model from that space and starts working on it inside of SOLIDWORKS. Before she makes any changes, it's best to do a where used search. The hand wheel is used in one subassembly below the master hatch assembly 2. She can open that right into her modeling session and get to work on it. Now she can see both. This version of the subassembly is released. So in order to make changes, Debbie needs to create a revision of the assembly and the hand wheel. The status indicators immediately show that the current assembly structure is out of date. So she replaces it with the new revisions and sets them to reserved. This gives her write access to the items she needs to modify without locking up other users out of the rest of the assemblies. The redesigned hand wheel looks great, but she needs to update the drawing. The shared bookmark gives Debbie quick access to the related drawing files. The drawing is now in sync with the part model. So she saves it to the revision B, then sets the part and drawing to a frozen state so they can be reviewed by Eric. Returning to the assembly, she finishes out the design by adding the latch mechanisms and saves the new revision back to the cloud. SOLIDWORKS takes care of the rest. Easy to use data management and lifecycle functions are built in. You're always up to date and the data is always accessible. In order to meet those tight deadlines, the Nemo team often needs to work on the same design files at the same time. Eric is working on a new revision of the master hatch assembly. These icons let him know Debbie has the hand wheel assembly reserved and is currently making changes. So she's working on the assembly and he's working on the top level hatch. He can reserve the top level without affecting Debbie's work on that subassembly. This modular approach to access control allows users to design concurrently without accidentally saving over each other's progress. You'll see a notification from Debbie at the bottom right. She says she's all done. Please review. He just needs to reload the latest version of the subassembly from the server. Then he can see Debbie's wheel. And then he can check the drawing. He likes that redesign. And so in the workflow, he can move it to released. She can't because she doesn't have permissions to do that. Back in the assembly, Eric attaches the connecting rod mechanisms then returns to his bookmarks to update the drawing for this too. Bumping the assembly and drawing to revision B, he's now ready to save. The revised hatch assembly requires new versions of the supporting documents. From the convenience of his Bookmarks tab, he uploads the latest version of the composer file and uses the interactive preview to check it. So cloud data management, very powerful. You can complete your designs faster without rewriting over each other's work. You can use this in a single user environment. You can use it in a multi-user environment. You can even have multiple projects going concurrently. This all enables you to complete your designs faster. So out of the box, cloud data management enabled the Nemo team to be productive right away. They were able to safely store their data, manage changes, and design concurrently, all without even leaving SolidWorks, that very familiar design environment. So everyone in the organization benefits when you connect SolidWorks to the 3D Experience platform. So now we're going to shift gears a little bit. We're going to go into more of the analytical side with simulation without limits. When you test your products virtually or in the real world, naturally, you're exploring numerous design options, evaluating how long they will last, and finding out when and where ultimate failure may occur. And it is no easy task. When simulating numerous physics and loading scenarios, collecting and making sense of all that data can be daunting and time consuming. This is especially the case when the design and analysis tools are disconnected or limited. But again, there is a better way. The 3D Experience platform does provide a collection of best-in-class simulation apps built with industry-leading technology, including Abacus and FE-Safe. And it connects seamlessly with SolidWorks, very similar to how SolidWorks simulation works. So Adam the analyst is working on the Nemo submarine to help satisfy their safety and certification requirements. Obviously, safety is going to be the major concern with something that carries human life. If anything goes wrong underwater, it can be catastrophic. So when it comes to the battery compartment and skid, he has a few remaining tasks. He's got to explore design variables to improve the Nemo. He has to evaluate its durability, and he needs to find out what happens if the submersible gets too deep. We have to give this thing a depth rating. So with a depth rating that we're aiming for of 100 meters, it is critical that the battery compartment can withstand the pressures beyond that depth to ensure safe operation. At the same time, weight and cost must be reduced wherever possible. Adam considers the thickness of the steel tube and stiffeners and defines the associated dimensions as parameters to be optimized. He saves the updated model to the platform and launches the Model Assembly Design app to start the simulation process. First, a mesh is created. The automated finite element mesh recognizes the thin components of the model and creates mid-surfaces and associated shell mesh bodies, all in one command. Next, he creates the structural scenario that defines the loads and boundary conditions to simulate the maximum designed depth rating, very similar to SOLIDWORKS simulation. At first glance of the results, it is obvious the structure is over-designed. Adam launches the Parametric Design Study app and selects the parameters and goals of interest and lets the computer do the rest of the work. When the study is done, Adam can easily interpret and compare the performance of the various configurations. The best design is even highlighted for him based on all of those things. You'll see a line there under feasibility that says best, feasible, feasible. If the design is not feasible, it will tell you so that that configuration is not valid. With one click, a new model and study using the optimal parameters is created so he can take a closer look. But he has additional tasks to complete first. So we automated the optimization of those parameters using this simulation tool. Next, those other things that Adam has to work on, the durability of the design. The pressure load on the battery compartment happens multiple times throughout the life of the Nemo. Another loading condition that repeats is the impact of the skid landing during storage after they pick it up out of the water and drop it onto the storage rack on the ship. To simulate that secondary loading condition, Adam creates an explicit dynamic study to accurately capture the rapidly changing stresses from the landing cycle. So how exactly does the skid come into contact with the floor? Adam lets the solver figure that out with one simple yet powerful general contact interaction. To greatly decrease the solve time, Adam chooses to run the simulation on the cloud, leveraging its high performance computational power. Adam can even shut down his computer while the simulations run, and we can use cloud credits to get this done using much more powerful available machines on the internet. The stress values are within an expected range, but how many times can the Nemo withstand both this and the pressure load? To reveal the answer, Adam sets up a durability study. He defines a fatigue loading that captures both events. For the explicit dynamic results, he includes all the increments to account for the fluctuations in the response, trying this at different depths, in other words. Adam also includes both stress and strain in the calculation to improve the accuracy and to solve for both high and low cycle fatigue. We actually cannot do low cycle fatigue in SOLIDWORKS simulation. Both sequences occur in the loading history, but they're exclusive events. So he turns off the enter event transition option. And lastly, he defines the base surface finish and solves for the result. The results are not only available to Adam, but they may also be reviewed by other collaborators from their internet browser so everyone can get the latest information instantly from one place. Now, you can run these simulations on a tablet. That's a huge game breaker, right? You usually have to have an extremely powerful machine to run through these calculations, but you can do this on a tablet. Comprehensive fatigue life evaluation on a tablet. Dynamic simulation on a tablet. You could do this on a smartphone. Any device, anywhere, anytime. But what about that worst case scenario? Adam's last task is to identify when and where ultimate failure may occur if the Nemo gets too deep. Leveraging the same study set up from the first scenario, Adam defines a Rix buckling step, which goes further than the typical eigenvalue buckling analysis that we're used to in SOLIDWORKS simulation, and is well suited for an unstable and nonlinear collapse of the structure. And it doesn't require setting up a more complex dynamic analysis. Processing the results is simple too. Adam loads the load factor and visualizes which areas of the component will fail first. These and all of the other results can be shared and reviewed with other stakeholders in 3D without the need to export or email. Everything is in one place. Once you have access to this dashboard, you can see this tab. By using the 3D Experience platform to explore numerous design options, evaluate durability, and understand the critical loading events, Adam and his team were able to make informed, timely decisions to help fulfill their safety and certification requirements. So wrapping up, we've covered on the surface and the deeper dive yesterday, and we've just now finished the last section of the 2022 3D Experience Works deepest capabilities and all the what's new content. If you guys missed anything from yesterday, again, that is going to be posted on the internet after everything is saved at the end of today. So you should see some of that stuff trickle out on our TPM Solutions YouTube channel. I hope you guys will join us for some of the sessions coming up. If you guys have any other questions that you'd like to ask about the 3D Experience platform or any of the tools you've seen today, you guys can enter those at this time. So taking any questions. Someone asked, how does this connect to SolidWorks PDM? I actually got this question yesterday as well, so I'll go into a little bit more depth. So SolidWorks PDM is an on-premise data solution. You have to have a server, you have to install everything on a server, and you have to work off of that server. You have to be connected to that server, which means that you have to have the IT infrastructure and everything on-premise in your office. There are hybrid methodologies for putting that, say, on Azure or another cloud platform. This is different than that. This is, you don't have to install anything. You just have to have a connector through your web browser that connects to SolidWorks, and you are connected to the cloud. That's all there is to it. And it updates automatically, and you don't have to worry about it. So you're connecting everything to the cloud like you would the Dropbox add-in if you're using Dropbox or GrabCAD. It's actually simpler than GrabCAD, in fact. But you're just working straight out of SolidWorks, and that application basically connects you to your cloud data storage, and it handles everything online. You don't have to install anything on a server, and it is user-based licensing, so each person has their own license. It's very different than PDM in that regard, in that you can connect multiple things to one user. Does simulation on the cloud come with SolidWorks? No, so SolidWorks is something that you probably already have. So you have your license of SolidWorks. The simulation tool itself, there are two paths you can go with SolidWorks simulation and with the platform. SolidWorks simulation does not occur on the cloud. All of the Simulia tools that I displayed, those are all on the cloud, and they are connected to SolidWorks. So you take your SolidWorks model, you connect that to the cloud, and from there you will actually do that in the browser in the cloud and run your simulations on the SolidWorks assembly in the cloud. But no, it doesn't come with it. Any other questions? All right, barring none. Thank you guys for taking a look at the 3D Experience platform, and our upcoming sessions are displayed here. So our next session, starting at 10 a.m., is going to be session 6 on design automation. We're going to have Joel Hanneman from TPM presenting on this one. So we'll hope you guys will join us in about 45 minutes when this next session starts, and we will see you then. Thank you, everyone.
Hey, good morning, everyone. Welcome to the next installation of the Technology Showcase by TPM. As you have probably seen on the agenda, this hour's session is all about design automation and CPQ systems, primarily driven through DriveWorks. So this will be an introductory session about DriveWorks, and it's a review of its broad capabilities, and followed by some demos. So we are here in the 10 o'clock hour, so we'll go ahead and get started. I can see we have a lot of people in attendance, so seems like everyone's ready to go. So welcome back. Okay, just a quick review of the agenda. We're going to start off with a PowerPoint presentation to, again, just do a light introduction of all things that DriveWorks is or can be. We'll follow that up with some demos from the DriveWorks live demo site. And then we'll leave some time for question and answers and potential next steps if you think that this is a technology that you and your organization might be interested in. Okay. If so, feel free to reach out to me and we can initiate that process. I'm Joel Hanneman. I'm your presenter today, Senior Tech Solutions Consultant with TPM. That's my email right there. So please be in touch if you have any other questions or if you'd like to follow up on this presentation. All right, so let's dive into it. So today's presentation, again, is intended to be a very high-level review of DriveWorks. Okay, we're going to throw a lot at you today. I think you're going to be surprised what the total range of applicability of DriveWorks is. And it's common to have to come back as an organization to reflect on how specifically that could apply to your organization. So because there's so much that DriveWorks can do, we found it useful to break all things DriveWorks into three what we call pillars of functionality. Okay, so the first pillar is what most people would consider sort of the traditional bread and butter of DriveWorks functionality, is all things design automation, and specifically for SolidWorks. So DriveWorks is a certified gold partner of SolidWorks. Okay, they've been in the SolidWorks automation business for approaching 20 years by now. Okay, so they're one of the original players in this space, starting off back in the days of Excel-based application and macros, and just trying to exploit all that can be done with the state-of-the-art upwards of 2 decades ago. Nowadays, everything is an API as far as just integrating one application to another. So SolidWorks, of course, has its API that it exposes to a whole range of functionality. And so these days, DriveWorks is a very robust sort of user interface to that API. In short, if you can do it with a mouse in SolidWorks, there's a pretty good chance that we can automate that with DriveWorks using the SolidWorks API. But fear not, DriveWorks is a low to no code environment. We'll see what I mean by that a little later on. So there isn't actually any programming per se. And that is the beauty of DriveWorks, that all the customized automation that's possible in SolidWorks is done through very user-friendly interface. Okay, so we'll dive into what all design automation is. But first, the other two pillars. The next is what we would call product configurator, or what the emerging industry term these days is CPQ. That stands for configure, price, quote. We'll dive more into what a CPQ system is, but suffice it to say that it is an extension of what your design automation might be of SolidWorks. Okay, so it, in short, enables folks either inside or outside your organization access to the power of design automation, typically set up by engineers and designers. Finally, there's the everything else. Okay, once we've harnessed the power of automation and we've built business systems around it, there's a whole lot of data that becomes widely available. And so DriveWorks pretty much puts itself in the middle of all your other business systems. Okay, making that data easily transferable and exploitable for any old purpose, whether it's for purchasing, whether it's for updating a CRM account field, or actually talking to your CAD system or PDM, whatever it is. So the everything else portion of DriveWorks is all things integrations, in short. Okay, so we'll dive into all three of these pillars in some amount of detail, and then get on to our demo. Okay, so let's first talk about what design automation is. I think the concept, the term sort of makes sense on the face of it, but let's dive into what that actually requires. And sort of you'll start to sort of realize the benefits of going through this process of making your design process automatable. Okay, so the first kind of broad level of work content is institutionalizing your design intent. Okay, so this is capturing all things design data, company policies, product data, know-how, experience, all that stuff that might exist in a binder, in a network drive, in employees' heads, in collectively in experience. or might just be floating around out in the ether, and it just sort of is what it is, and people kind of tend to know it within the organization. All that is design intent that, in order to be automated, has to be captured somehow, some way. Okay, so the process of doing that, we're going to distill all this disparate information and know-how into some sort of actionable and logical format. Okay, and the result of doing that is we create the single source of truth for all things product design. Okay, whether it be how a certain dimension reacts to a specification of the product, to what building code applies to that structure in a certain state, whatever it is, all the hierarchy of design and engineering content that is required to successfully build a product, we do need to capture that and institutionalize it, thereby making it actionable in a logical sense. Okay, so once that institutionalization has taken place, then we have to create some sort of design process. Typically, that starts off with building a form, like you see here on this slide. Okay, so somehow we have to guide the user through making selections, entering values, making choices, determinations, whatever it may be, but somehow guiding the user through an established process. Okay, like I said, typically this tends to be in the creation of a form, as customizable, dynamic, and sophisticated as it may need to be. And throughout, we ensure that data is validated, we're causing the right choices to be made, and that any sort of cascading decision making that results from a prior decision is successfully presented to the user, so on and so forth. So in doing so, we're instituting a highly controlled design process. Okay, we're capturing it and then putting that into a graphical presentation such that your user group can interact with it intuitively, quickly, and in a way that just makes the design process all the better. Okay, the form that you see here on this slide was custom made, and we will dig more into what that means later on. Okay, and then the final process is the actual automation. Okay, seeing the action, seeing the activity, and enjoying all of the work that was put into the first two steps. So automate means taking all that institutionalized content and operating at the speed of your hardware, okay, of your workstation, of your server, of your machine in the cloud, wherever it is. Whatever machine has SolidWorks has the ability to create a variety of document formats, whether it be Word or Excel, PDF, XML, the ability to export to a database, whichever machine or sets of machines that you so choose, the automation will work at the speed of those machines. So obviously much faster than human hands. Machines don't make mistakes. So obviously huge error in reduction in errors, manual errors. The result of all this is that as an institution, you can start to shift your human resources, your valuable design and engineering resources, from doing all that repetitive stuff and now focus on more valuable activity that humans are actually good at and maybe machines aren't. So oftentimes companies that are in the process of adopting DriveWorks are starting to experience automation for the first time in some real and practical way. And once the design automation bug bites, quickly everyone starts thinking about, well, what else can I automate? How else can I extend this platform? How far can this newfound sense of automation reach? Which brings us to our next two pillars. So CPQ, configure, price, quote, is just that. It's an extension of the work that I just described to make design automation successful. So to the extent that we've captured all company policies, all product data, all your workflows, all your processes, etc., and we've built a form that it makes sense for a user to use, we can take that and push this whole workflow into a more public domain. Public is defined by however your organization wants to proceed, but that could just be out to your internal sales team, to an external sales team, to your distribution channels or out into the general public domain. What is fairly consistent with the implementation of the CPQ is that it is a web-based deployment. Okay, so everything that you would experience, and when we take a look at demos later on, you'll see that that is all being handled through a web browser. Okay, so as sophisticated as all this content that underpins your design automation, how sophisticated that can be, we're essentially going to deliver that through a website. Okay, and in such a way that just about anyone can be guided through designing their product successfully. Okay, so what this ends up enabling is further and deeper control of your sales process as a whole, particularly if you're a company that manufactures customizable or configurable products. You know firsthand how tricky it can be for sales and design and engineering and production to all work perfectly in sync. You know, there's the interdepartment dynamic between and a company is just hard to avoid. No matter how tight your processes are, there's always more opportunity to clean that up and make it more of a single cohesive system. And that's what DriveWorks enables, particularly in the CPQ space. Okay, and then diving into everything else. This graphic showing the cup with the rocks in the water is a nice analog to how, in our experience, most businesses tend to operate. The cup you can envision being the business. Okay, the rocks would be individual or disparate business systems, disparate departments, even individuals. It could be, you know, the handoff of a packet of information from one person to another. It just represents these individual things that need to communicate with each other. Okay, and as you can tell by the rock analogy, these rocks are barely touching each other. There's, you know, a little bit of one rock surface is touching just a little bit of the other rock surface, and they're barely touching. That represents the fragility of that sort of communication within a business. So what DriveWorks does, you could say, is adds the water to this mix, thereby creating a much more robust connection around all these disparate systems. So instead of your company relying on how fragile any given step along the process might be, we can now make that much more robust, institute controls, determine the who, how, why, what, and when, fill in any gaps. Big buzzword these days is establishing a digital or enabling a digital transformation. Okay, when you consider all this together, DriveWorks really becomes more of a platform than just a piece of software. Okay, that just runs some SolidWorks automation in the corner office, right? So it can now become the system that the whole business starts to use as one, because if you're a manufacturer of configurable product, that core data about your product is what the whole business as a whole relies on, okay, no matter what department you're in. So we can use DriveWorks to create that robust connection throughout. Okay, how do we do that? Well, DriveWorks, you could say, in this this particular topic is just a very robust, complete, and user-friendly middleware for handling all things data. Okay, so there's a lot thrown onto the slide on purpose just to demonstrate the wide range of opportunity to enable everything else with DriveWorks. So we have out-of-the-box, user-friendly interactions with all your major database types, with all of your typical text-based data files like Excel, whether it be Excel, XML, CSV, JSON, et cetera, et cetera. There are out-of-the-box third-party software integrations. And then if that doesn't do it for you, we can start to take advantage of web services, APIs, and the SDK via DriveWorks to do highly customizable integrations as needed. So, but the typical use case for this everything else pillar is using just native out-of-the-box functionality in DriveWorks. Okay, we won't dig into, you won't witness any of this. We're not going under the hood on anything today with DriveWorks. So a lot of folks want to know how all this stuff works. We can dive into that in the subsequent sessions with your organization if that's something you wish to dig into. Okay. The notion of DriveWorks fulfilling the everything else pillar relies on how customizable it can be. If you have experience with other business systems, you've probably come across situations where a certain form or a template can be maybe altered. You can add an extra field to your sales order, or you can add a couple extra lines to a purchase order, or maybe you can hire someone to whip up a little piece of code that does something kind of specific in between your ERP and your CRM system. But at the end of the day, none of those systems are in of themselves designed from the very beginning to be customizable, right? They serve a purpose. You can go outside that purpose, a couple degrees here and there, but really you have to operate within the confines of what that system was designed to do. DriveWorks, on the other hand, was designed from the very beginning to be completely customizable. It's in its DNA. Okay, so literally everything that you come across in DriveWorks under the hood, there is opportunity to make it completely unique and customizable and directly applicable to what you are trying to achieve. The best visual example of that is in your form building. Okay, so this little grid on the right of the screen shows what a form looks like right out of the box in DriveWorks. Okay, compare that to several slides ago, we had this form here. Before this was created, it was just a blank screen, literally. So building a form is a lot like using PowerPoint. Okay, you start off with a blank slide, you drag in images, you drag in little buttons, you drag in videos, you drag and drop. A lot of drag and drop, a lot of changing your fonts, making things look just right, the colors, this and that. The experience is similar in DriveWorks, although there's a whole lot more sophistication behind that. So at the end of the day, we aren't just taking a template form, excuse me, kind of bouncing around here. We're not taking a template form and allowing for some, I don't want to use the word customization, some alterations of that template, and that's it. I mean, it is literally a clean slate. Okay, and we'll see how that is. This is all, again, happening in a low to no code environment, so there's no programming. Okay, so everything else also involves establishing a workflow. Okay, what exactly happens when you process a quote? How does that quote turn into a sales order? How does that sales order get released into production? Okay, your company probably knows these things already, but it might not actually be maybe fully documented. It might just be generally understood. It's just these rules kind of exist in the atmosphere around the business, and you kind of generally abide by that. Well, in DriveWorks, we have the opportunity to actually create those in real and actionable terms, okay, where you can, from scratch, again, just using your mouse, build out a workflow that the DriveWorks platform is forced to follow, okay? This is a very basic workflow. This might represent just a very rudimentary quoting process where the first step, you enter some data, it gets processed. Okay, we've generated a quote. There's a review step, maybe by a sales manager, or a review step by the customer. They can reject it, then it goes back to an entry state. And so there's a sense of a loop generated here, or if it's ultimately approved, it goes into some approved bucket, and then ultimately that quote is completed. So, extremely rudimentary, very top level, but just establishes this thing that is a workflow, okay? To get more granular than that, we actually start to control processes. In DriveWorks, we call these macros, which is, if you've got some experience actually using macros in other applications, it's a similar concept, but it's, again, very WYSIWYG, drag and drop. What you see is what you get, okay? So each one of these, we have 3 separate macros here laid out just to establish, hey, this is like a very basic macro, here's an intermediate macro, here's a more sophisticated macro. Each one of these gray boxes represents a specific type of action or condition or assessment, etc. There are hundreds and hundreds of these tasks that we call them. You can think of them as tools. It's sort of like walking into a Home Depot to buy all the tools and all the materials that you need to put up a house. So Home Depot will sell you all the stuff, but it's kind of up to you what order of operations you want to set up, what exact tools you need to use, what size you want to cut the wood to, etc. That's up to you. That's up to the beholder. That's up to the person who actually knows what they're trying to achieve. So each one of these tasks is dragged into your workspace. And of course, you can see that some sort of flow has been established. We have introducing a logic every step along the way. So if this task here is calculated with a certain result, we'll go this direction. Again, if it's calculated in another way, it goes this direction, et cetera, et cetera. So this might be, okay, this is the actual chunk of activity that happens, let's say during this review, or this review step. So someone hits the reject button. Okay, what does that mean? I'm just gonna make this up on the fly, but okay, the reject button is pressed. We're gonna have a task that checks, well, who rejected it? If it was the sales manager, send it off to the sales associate. Okay, if the sales associate then checks it and thinks it was wrong, then they can pass it off to the customer. I don't know, whatever the situation might be, all that stuff is very controlled in a granular fashion, setting up processes, okay? All right, all of this is underpinned by the ubiquitous DriveWorks rule builder, okay? And this is about as code-like as it gets. So if you have some amount of experience writing formulas in Excel, and you're hereby qualified to write rules in DriveWorks, okay? So perhaps you've used an if statement in Excel to calculate some sort of logic, some sort of result. Using an if statement in DriveWorks is all the same. You know, you have the same three arguments. You know, you have to present a condition that can be evaluated to be true or false. If it's true, then you're going to perform this. If it's false, then calculate that. You know, the syntax is very user-friendly. It's syntax that really any designer, engineer has most likely come across in their work life before. So the adjustment to creating a highly customizable environment in DriveWorks is rather quick. Okay. So this rule builder and the ability to introduce logic exists at every step along the way, literally. So each one of these little fields within each one of these tools can all be written in a way that is precise to the need at hand, okay? Okay, so that's a very quick overview of all that DriveWorks is. Again, we're not gonna dive under the hood per se, so the remaining time I'm going to go through real working demos on DriveWorksLive.com. That is a demo site put on by DriveWorks, the software company. We will go through a variety of demos to kind of compare and contrast what a system might look like and what various capabilities could be enabled. And we'll leave some time at the end for a little bit of Q&A. Okay. Let's switch over to our browser. Okay, so I'm in a browser online. This is DriveWorks' own site. This is all things demos and all things information, detailed information about how the product works. Okay, so I would personally take note of this address, and you know, on your own, go ahead and study some of these examples. Furthermore, before we get into the examples, I do want to point out that at the very bottom of this page, you go past all these industry examples, you get to, well, there's some videos on what CPQ is, okay? DriveWorks has produced a nice series of videos that shows how various parties within your organization or even within your supply chain can take advantage of DriveWorks as a holistic system, okay? So that's a pretty interesting look. I would recommend just taking a few minutes to watch that. And then at the very bottom here is a section called DriveWorks Technology. These are the tech stacks that describe the various elements of how DriveWorks does what it does. Okay, so for example, they have a demo on writing rules. So if you are here listening to this today saying, huh, this DriveWorks thing is kind of interesting, I can see some opportunity for our business to take advantage of that. I would say the first thing you want to do is come to this site and take a quick browse just to become an informed consumer of what DriveWorks can do for you. We can certainly dive into any of this stuff that you're about to see in more detail on a case-by-case basis. In any case, all of these are actual live working demos using DriveWorks as a software. So they are actually using DriveWorks to demo DriveWorks, which is a pretty cool concept, okay? So once I click that Explore button, everything that is within this outer gray box was produced in DriveWorks. This little pop-up menu with a little introductory bit, that was DriveWorks. I clicked that button, that was DriveWorks. This gray, this white, the text, the imagery, all these buttons, that was all produced using the DriveWorks form builder environment. Again, that WYSIWYG drag and drop functionality gets us to the point of what you see here. So if you're interested in what interfacing with the rules builder is all about, what the capabilities are, this is all like a real working demo, kind of outlining that in all sorts of detail. Okay, I'm not going to go through this right now, but just understand that this explanation is here for a deeper dive on your own. Okay, so I'm going to X out of that demo and move on to actual industry demos. Okay, so let's pick out a few compare and contrast. So let's do the cover demo. So this is loading. Why is it loading? Well, let's think about what's going on. So I'm in North Carolina accessing a server that exists in the UK. Okay, DriveWorks is a British company, by the way. So it does take a little bit of time for all this content, all this functionality to actually be rendered, to be downloaded into my browser locally and to be rendered. Okay, and all the assets that come with that from a web technology standpoint, there is some amount of loading to be done. But once it's loaded, there's quite a bit to behold. So first thing you notice, and again, just to reiterate, everything within this kind of inner rectangle in my browser is DriveWorks, okay? First thing you notice is there is a rather attractive and complete 3D rendering of the product, not just the product, but a surrounding scene featuring lighting, featuring textures, the ability to zoom and pan and move stuff around, okay? So that's fine and dandy, but actually, furthermore, it's fully interactive and reflective of what the user is inputting into the form. So this is a very basic product. I appreciate that, and you might look at this and say, well, that's just a silly cabinet. Our product is a lot more complicated. We'll circle back to some more complicated situations. So in any case, for the sake of a demo, DriveWorks came up with a form that even someone like me who doesn't know much about cabinets can go through a design process for a cabinet product. As I make choices, keep an eye on our pricing off to the bottom right. I make the thing bigger, obviously it should become more expensive, which it does. Okay, there's more steps than that. We have to pick some material. We can pick a painted surface, or we could pick a wood surface. I'm going to stick with the paint. Get some fancy green that looks kind of nouveau-ish. Okay, I can swap out different types of doors. Okay, looks nice. And I can also swap out hardware. Okay, so just a quick note on what we're actually observing here. This is not SolidWorks operating through a browser. Okay, this is DriveWorks' own proprietary 3D rendering technology that is built to be web enabled and web performant. Okay, there are underlying SolidWorks models that were used to generate the content that we do see, but when we are making selections and watching things change in front of our eyes, that is a separate technology that is separate from SolidWorks. Okay. Okay, that concludes the actual design process for that cabinet. But what they're going to show us is the ability to, in a real-time basis, see what a cover letter might look like right off the bat, or what a quote, a formal quote, might look like right off the bat. Okay, because all that design intent has been captured and stored away in DriveWorks, we can produce a quote right away, right here, right now in the website, or we could choose to have it emailed, or have it be, have the salesperson call to follow up. Whatever your workflow is that you determine is how that would flow, and the exact process would follow accordingly. But just for sake of demo, we can make all sorts, we can just understand that all sorts of product and sales information is available right away. That's the bill of materials. Here's a cut list. Okay, so we're ready to go start manufacturing. If this button were to say order, we could have all the information ready right away to go initiate production. Okay, so let's hit complete, see what happens. It's going to ask me for some information. And I will show you that within a minute or two of clicking submit, I'll show you the email that gets sent to me automatically. Again, just by example. Okay, so one thing that they're going to show us right away is the activity on their servers happening in real time. Okay, so it's going to take a few moments here to load, but we have already produced an actual PDF quote document that we can download, or it's probably in an email on its way to me now. There are 15 models to be generated. This is actually happening in SolidWorks right now on their servers in the UK. It's already done 2. That's going to progress. After that, it's going to produce 6 drawings as a result of those models. Okay, and it'll keep updating this list of stuff that's been generated as it goes. And it'll keep, just for fun, they're creating images of each part file or subassembly or assembly that was created, just to say, hey, that was just made right now, real time, just for you, just for Joel. That nice yellow cabinet he designed, we're working on it already. Okay, so we'll let that work in the background. We don't need to watch that until completion. And let's take a moment to look at a contrasting configurator. Okay, so this is the HVAC system, which you will see is an arguably much more complex product. Okay, again, we're operating through the browser, but everything within this smaller rectangle was generated in the DriveWorks form format. What you're going to notice pretty quick is that there isn't any actual 3D, what we call 3D preview, that fully rendered, dynamic, actionable kind of workspace that I, as a user, could interface with. Instead, we have some pretty pictures, which is nice. That's better than nothing. That's better than just a white form with black text and no supporting imagery. So we've got some rendered images that gives the user some visual support of what they are working on. Okay, so here's just a snapshot of the type of product. This is industrial or commercial grade HVAC systems that would be on top of a manufacturing facility, etc. So the ultimate output of their DriveWorks platform is quite comprehensive. There are thousands and thousands of components. And we will see that the configuration of this HVAC system is completely customizable. We choose what we want to add. We choose how it comes together, et cetera, et cetera. So let's start configuring. Now, they have designed this form workflow very particularly. Okay, so they won't let me start configuring until I make what they determine to be kind of an initial critical choice. Okay, I have to choose what kind of connection method there is between the HVAC system elements, and I have to spec out an airflow, because sure enough, every decision that's made after this will cascade from this original decision. So they put that first and foremost. They make me answer this question, then I can proceed. Okay, Next, logic would hold that you have to choose the entry module rather, before designing the rest of the system. Okay, that's what they want to do. That's what I'll follow. I get to choose the entry module type. As I make selections, the imagery in the form changes, but this isn't 3D. I can't spin this around and interrogate it. It's just a basic rendering. Okay, so I'm going to make a choice. Of course, the price is getting updated real time. They've got notes that I could browse to understand better what I'm choosing. That's all good. Once I've made that initial choice, now the world is my oyster in terms of HVAC design, and I can add and configure as I so choose. Okay, I need a heat exchanger. Great, let's add that first. Spec it out, pick the type, add. Great. Now I need to add another component, the heat recovery. I'll choose safety hoops with rungs. Great, 31 grand. Oh, let's add a window. Oh, that affects the price. Okay, great. So on and so forth. Okay, so I could keep adding and adding and adding in such a way that the final top level assembly, as you might imagine in a CAD sense, is content that is novel, right? This isn't some pre-configured option. The sequence of me adding and configuring more and more and more is new and unique to this session of me as a user. Okay, so I could keep adding and adding, but let's just go to the end and add the final exit portion, which is required to complete the design, and we're done. They're saying, hey, are you sure you want to be done with your design? Great. Okay, so they've chosen for the sake of demo to itemize each of the modules that I've included. I could view the BOM again right away. I could view my quote right away, etc. All that content is already available. Again, because we started with the principles of design automation are institutionalizing all this content to begin with. So once it's institutionalized, it's captured. Now it's available for anywhere in the business to take advantage of, including the quoting step of sales. All right, so let's go ahead and confirm this. I have to enter my information again. Submit. Per their workflow, it's going to accept my order. Okay, and again, bring me to this this view where I can just sort of check the status of my quote request. Okay. Meanwhile, let me check my email. Here's the email I got several minutes ago regarding the my cabinet. Oops, there it is. In the email sent to me is the image of that cabinet that I designed specifically with the price. Unique company cabinets has fulfilled my quote request. They sent me a formal quote. Here it is. I can print it out if I want. Here's my cover letter. I can print that out if I want. Point being is that this was generated immediately. And this is over 5 minutes ago that this email was sent out. Okay, so that's the workflow that they chose. The exact set of documents that was attached was all programmatically considered. The actual formatting of this email is all custom made, et cetera, et cetera. Okay. So that's the HVAC system. Now let's go to a more interesting case study in all things configurator. I think that'll take about another 5 to 10 minutes, which will leave us with some extra time for some Q&A. Okay, let's go to shelving. So again, for the sake of demo purposes, this is a rudimentary product. Okay, so it's less about the depth and detail of the product, more about just an overview of capabilities. So in this particular demo, we are going to, step one is, hey, okay, great, you need shelving, but where's that shelving going to go? We're going to give you a visual reference to help you think through that process. Okay, this is all in millimeters because they're a British company, but you know, we are free to spec out this room as we see fit. And as you'll notice, the room is changing right in front of our eyes. There we go. Next, we have to actually spec out the shelving style. We can choose various materials, or we can choose a duty rating, and then that will limit our material choices. We can choose some add-on accessory items like casters or feet. We can pick a color. That's pretty gross. Yeah, not mint. How about khaki? That's fine. And some blue. Yeah, we'll pick some various colors just to show that it's reacting to our choices. So we're gonna do we're gonna do aluminum and super heavy duty. Great. Well, if it's super heavy duty, you can see that the wheels choices is no longer available, right? For whatever reason, maybe the wheels aren't rated for whatever super heavy duty is rated for, right? So they have taken that option away from me. So as a user, they won't let me make a poor choice, okay? I might want to choose anchored. Oh, if it's anchored, that opens up the steel option. So just, you can see how the form has been set up to be dynamic and responsive to my choices. And in doing so, it is reflecting their company policies, the product restrictions, et cetera, et cetera. Okay. Great. Now I have to actually spec a size. Okay. There it goes. Pick the bottom shelf, and I'll pick 3 shelves. Okay. Now the 3D portion of it. Oh, there it is. Generated real time for me right here in this 3D workspace with my beautiful arms, with the color match leg system. I've got no casters, and this has been built to my spec for the size. Okay, I can add an extra bay. There it goes. My extra bay I can put at an angle. Okay, I need my shelving system to go over here, et cetera, et cetera. So again, this content is all novel. We are not working within a pre-configured logical system, right? We are enabling the user to make a truly novel designs, okay? So we're gonna end that row and enable the user to actually do that again. So we can design a totally different system. Whoops, oh, here we go. I think I modified the wrong one. There it goes. So you can see we now have a uniquely designed product in concert with the other uniquely designed product, all actionable in a graphical sense and in a way that someone like me who doesn't know anything about shelves can start to engage in the actual design process. Okay. Again, everything that you see within this rectangular space was generated in DriveWorks using that customizable form builder environment. Okay, final little demo bit here. We're gonna take this concept of working in 3D within a workspace and having some sort of first degree of flexibility in designing different variations of products and take that to an extreme. Now we'll go to the factory layout example. Okay, again, per their workflow, I have to choose, let's say, a factory type. Great, it's gonna render that for me real time. There it is in all its glory. And now I need to add stuff to it. So this presents the notion of adding what you might consider standard product versus configurable or customizable product. A standard product would come out of a catalog. So great, we've got gantry cranes. Let's add a gantry crane that isn't necessarily configurable, but there are a range of options. Okay, so let's take that 500 kg unit. Great, it's got a price. You know, within that sort of catalog sense, I can maybe spin around in 3D or just limit it to, you know, a static image. Let's add it to our factory. Okay, there it is. We can relocate it, put it wherever we want. Great, now let's add something customizable. We already did shelving bay. We already know what that's about. So let's go ahead and talk about a customizable conveyor line. Again, they're causing me, the user, to make various choices along the way. So I get to spec out the conveyor and then now start adding components to this customizable system. There it is, per the height, per the width, per the color. I can add another straight, add a curve, add a straight, add a curve, whatever it is. Okay, let's say I'm done with that system. I can complete the design of that. Real time, the result of all of my inputs are being calculated on their server. It's going to take a moment to actually produce that unique design that I just came up with, render it, and make it available to incorporate into this layout, thereby making, conjoining the idea of working with configurable product side by side in the same environment as a standard product. Now, you could, obviously get pretty creative with how you might want to be able to like control the exact positioning, what kind of, maybe you might think of these as mates, like how you want to actually have these things interface. There's all sorts of possibilities for pursuing that line of thinking. But plain and simple, this is a very capable and complicated, sophisticated example of what a complete DriveWorks platform could be. Okay, what else? So I have one more product here just for fun. Your robot arm. As you can see, the price for the whole system is updating in the top right. I can add that arm somewhere, maybe at the beginning of the, that looks good. So it's going to pick from a pallet, load it onto here, then it gets lifted. Okay, great. Now we can view our quote right away. There's the price roll up, close a quote, and we have some viewer options. We have QR code functionality. At home, if you were to do this demo yourself, you could actually enjoy some of the benefits of AR and VR capabilities within DriveWorks. And even, so if you were to scan that code with a phone or a tablet, you could actually hold your phone up, scan around the room right where you are, and see this factory space being rendered right in front of you. So, that might all sound like fantasy grade stuff right now, and perhaps it is for most companies, but if you're keeping track of technology and what's going on with all things software and the future of software these days, it's going in that direction. So I only bring this up to know that DriveWorks is on the forefront of that. It has been all the while. Okay, well, right on cue. I intended to leave about 10 minutes left for some Q&A. So we can go ahead and engage on that. Just one more thing here on the presentation. Excuse me. Come on. All right, there we go. Some time for questions and comments. Just a quick note on what's next before we wrap up. Again, be in touch. You can be in touch with me directly or through your sales executive at TPM if you would like to set up a session to learn more. Our typical process is to take you through a presentation like you just saw now, perhaps with a larger group in your organization. But also we would start to get under the hood, because we do advocate for understanding in more detail pretty soon in the process, how DriveWorks works, what a day in the life of using it is, what the realities of implementing the system, what that reality is. So all that we can offer as a follow-up session to what you see here. So given that, opportunity for some Q&A. So I believe you can chat your questions directly into the webinar interface. I can see them there. So we have one question here regarding what this software, if I could interpret the question, how is this software offered? Okay. It is important to note that there are various tiers of the DriveWorks application. There is what is the kind of introductory level is what is called DriveWorks Express. That is actually offered with every seat of SolidWorks. It comes kind of baked in as an add-in. So you can activate that add-in, and through your SolidWorks portal, you do need to get a license code of sorts. You can activate that on your own through the SolidWorks portal. Okay, from there you can start to use the add-in, and there are some resources on the DriveWorks website, some how-tos, some introductory, I guess you'd call it training. But it's a simple platform, but it gives you a very first taste of what automating SolidWorks files is all about. Okay, that is not meant to be actually used in any production sense. It's just literally an introductory sort of teaser application. The next step up from there is what is called DriveWorks Solo. Okay, so that is a nice bridge from that teaser software to everything that I just showed you today. It is a standalone application that works in conjunction with SolidWorks. Okay, that does require a purchased license. However, there is I believe it's a 30-day free demo is available for Solo. So if you think you're interested in, but you really want to kind of dip your toe in the pool to check it out, that's the put your own hands on it. That's the best way to get started. Then the final tier is what is called DriveWorks Pro, and that is actually a collection of about 6 applications that are used for various purposes. Okay, we're not going to get into detail about what each application does, but it is sort of an a la carte purchasing situation where if you only want, let's say, if your business is only interested in this first pillar of CAD design automation with SolidWorks, you only need a couple of the modules. Whereas if you want to engage, enable that web-based online platform, have these fancy 3D images in your form and all that, that requires purchasing of other modules. So the pro level system is, like everything else that DriveWorks does, is customizable in how you purchase and how you deploy the software from there. I'll add on to that DriveWorks is, I would say, as close to a do-it-yourself type software of this type as it comes. There are other design automation softwares out there for SolidWorks. However, they all require basically engaging with the vendor to produce the system for you. Whereas DriveWorks stands out as the sole offering that is, if you're so inclined, if you're pretty technical and hands-on, you can purchase licensing, take some training, probably get some support service along the way, but otherwise deploy the whole platform as we've seen it today on your own. So that is a major way that DriveWorks stands out as a automation solution that works for the masses. Okay, a few minutes left. Let me browse questions here to see what else we can talk about. Yeah, there's a question about managing data and like how complicated the data can be. So I'll kind of rephrase that question to be a bit more broad. So as we pointed out before, there's the everything else portion of DriveWorks, okay, which implicates the idea of reading data from other sources and writing data to other sources. To the extent that that functionality is built into your platform in a real-time basis, handling data is something that you do have to start to imagine from a performance standpoint from the beginning of your implementation. So for example, let's say in your form you have a drop-down field for picking a customer. Okay, you might have 10,000 customers. Okay, well, first of all, we don't want to have that list of 10,000 customers exist in your CRM system and your ERP system and now separately in DriveWorks. That doesn't make any sense. Now you have these 3 separate sources of data. Which is the single source of truth? Is there one now at that situation? So probably not. So we always advocate for having the single source of truth. maybe in this scenario, all things customer data ought to live in the CRM system. So that form in your DriveWorks platform that pulls, that shows you the list of available customers, the source of that data is the CRM. Now, do we want to import or run a query against your CRM database every time someone wants to fill out a new quote anywhere, in the world over the internet and run that 10,000 record query? Probably not. So instead, you might say, well, you know what, we only need to refresh the list and database, every hour or once a week or once a year, or maybe like your price book. You update your prices every quarter to reflect material volatility. Whatever the scenario is, we can decide, okay, well, yes, you do in fact need all that data in DriveWorks in order to perform, but we don't actually have to actively go retrieve it real time every time. Or maybe we do, but maybe instead of getting, if you need the latest price on a certain profile of steel tubing, let's go get the price out of the materials database on a real-time basis, but we're only going to query for that one particular piece of data. That way, our query is not huge. We can run a query against a database in a millisecond and get that, keep that live dynamic connection between DriveWorks and your other systems intact without bogging down the performance. So data management does become a thing, and it is important to kind of recognize that early on, and I don't know, I guess I'd say not build a monster of a platform that once you try to put that online starts to become pretty slow. Final question here is about, I'll just reinterpret this as sort of generally wondering about websites and how that's all integrated. That's a good question. So just to kind of distinguish or kind of point out various ways that your DriveWorks configurator can actually exist within your company's website. Well, it's typical to have, a button. You'd have like a drop-down menu or a button that says, hey, here's the link to our configurator. You click the button, boom, you open up a new, let's say either a browser page or a new kind of window within your browser. And then from here, you are rendering your DriveWorks project through the browser. If that's the extent of the interaction that you care to have via your website, that functionality is handled right out of the box with the DriveWorks Pro software suite. Now, you can choose to become way more sophisticated than that. So for example, here is a configurator that's built directly into the website, okay? There's no kind of like intermediate step between browsing your company's site and actually interfacing with the configurator, okay? It's all happening real time right here. And it can become way more sophisticated than what we're seeing here, where if you have someone log into your website through like you might have an existing customer portal, they log in, oh great, let's take that information from the website, pass it into the DriveWorks project. Because of our settings in DriveWorks, we know, okay, that particular rep or that particular customer who has just logged into your site, we give them certain permissions in DriveWorks, and what we show them as a result real time is based on those permissions. So again, a pretty heady opportunity for integrations, but in order to do that, that does implicate going down the road of custom website development, which is getting into custom HTML files, CSS files, JavaScript, etc. That does kind of depart the do-it-yourself development domain that everything else DriveWorks is all about, and puts you more into the website development domain. So that is an important distinction, but let it be known that between a DriveWorks developer and a website developer, the world is your oyster in terms of how you want to deploy a system online. Okay, I think that's the last question that we can field here. Just past the 11 o'clock mark. So our time is up for discussing DriveWorks. Thank you all for attending and for your attention. Again, if you have any desire to follow up, please do so. for a few minutes, I'll leave the contact information up here. And if you do, I look forward to catching up with you soon. All right, enjoy the rest of your day.
All right, everybody. My name is Tony Glockler with SolidProfessor. I want to say thanks to the folks from TPM to having me join the session. Excited to be speaking here and talking a little bit about SolidProfessor and also about how to keep your design team's skills up to speed, especially with all the different tools and technology that are becoming available, in addition to very specific, I say, capabilities inside of SolidWorks and other engineering-based technologies. So this session is going to be talking about SolidProfessor. Some of you might be familiar with it, others maybe not. I'll talk a little bit about some of the reasons for maintaining proficiency, and do a short demonstration of SolidProfessor, the platform. So first of all, a little bit about me. My name is Tony Glockler. I'm the co-founder of SolidProfessor. Background is as a mechanical engineer and very much kind of a CAD geek. That's what led to founding SolidProfessor. I'll do a deeper dive, but as the name suggests, we do learning for engineering design topics. But very excited to announce that one of the reasons I'm presenting here today is that SolidProfessor is now part of the new TPM One subscription program, and we're super excited to partner with TPM, the good folks over there, and help bring some more value to all of you on the phone, trying to help address any of those ongoing challenges with maintaining proficiency, learning new capabilities, getting up to speed with the fundamentals, and being part of a package and an organization that's helping to bring more value to their customer base. So with that, a little background on SolidProfessor to put a little bit of perspective on, okay, we've got SolidProfessor as part of TPM One subscription, but what is it? And how does it help my team? So what we do is we provide a very comprehensive online video-based library covering topics primarily on the mechanical side of things. So CAD tools, cover CAM, cover engineering theory, and then we also expand out in some of the other Autodesk titles as well. We've been doing this for almost 20 years, and we work across both the commercial markets, so a deep library of course material to help engineering professionals, as well as we work with I would say thousands of schools across the US and around the world to help prepare students for engineering careers. So to dig a little bit deeper into what are some of the topics that we actually cover inside of SolidProfessor. So I'm going to just do a quick high level here, and then we're actually going to dig into the platform a little bit and talk a little bit about it. So we cover topics from, as I mentioned, from SolidWorks all the way on the engineering design side, all the way through GD&T, design for manufacturing, on the CAM side, Mastercam, CamWorks. We also cover kind of engineering theory related things, so engineering graphics and spatial visualization, FEA, really kind of a broad suite of course material to help any kind of tools and capabilities associated with engineering design. A little bit about the SolidProfessor learning methodology. How do we approach learning, and why is it important? So I mentioned this session is going to be about maintaining proficiency and some of the challenges there. As anyone that's on the call knows, that the biggest expense for an organization, whether you're an individual contractor, you're running your own consulting business, or you've a large engineering design team, it's really the people that are the most important part of the equation, both from a skill set and getting work done, but also for taking advantage of the different capabilities that are available to you as an engineering organization. So there's clearly a challenge because there's all these complex tools and technology. And due to the complex tools and technology, it's not just about learning, but it's also how do you understand the skills level of the team? How do you provide learning and learning resources to keep up with those capabilities? And at SolidProfessor, we have a belief that learning is not a one-time event. It's about continually going back, refreshing your skills, understanding new capabilities, and being able to do that in a very efficient, effective way. Going through a full day session with an instructor where you can learn a tremendous amount, especially if you've got a fantastic instructor like the folks at TPM and their technical team, but people don't always have time for that. And so a way to stay on top of those capabilities is by having a resource like SolidProfessor. And what we are is it's an online video-based library of course material. And the way we make the content accessible and referenceable and bite-sized, so you're able to take advantage of learning when you have a challenge or when you have time. All of the lessons in our library are very short, typically less than 6 minutes. The content is accessible everywhere, so it's web-based. We have a plugin inside of SolidWorks, so you've got quick reference, or anywhere you've got an internet connection, you've got access to the entire interface for SolidProfessor. Is part of the learning process. It's not just about what you learn, it's about what you've retained. And we also have interactive quizzes, so be able to test your skills, get a sense of how much of the content, the material that you've gone through, you've actually internalized. It's one thing to go through learning, it's another thing to actually embody that and make that part of your daily practice. Another part of that is interactive exercises, so a way to put your hand on the mouse and be able to reinforce the skills that you've learned. All the content is expertly curated, so we have a team of experts on our team on all the different theory that we cover. I should say theory and software topics. For those areas that we don't have the in-house expertise, we partner with the best in the industry. And then part of that, and kind of another component to our learning methodology, is kind of celebrating the wins, I like to call it. So it's not only about learning the material, but how do you show off what you've learned. And so we've got technical certificates, and then for those that are maybe managing a design team, we also have insights into what's happening of your engineering team, so you can get insights into how well people are progressing. You can customize the course material, kind of use it as an ongoing learning resource. So a little more about technical certificates. So I talked briefly about the idea of how do you celebrate the wins. So this is one of the items that I'll be sharing with you once we get into the platform. But for each of the different courses that we have in the subsections, if someone gets through the different section and scores well on that test, you can earn a SolidProfessor technical certificate. And this is a great way, either as an individual that you want to prove your skills and your capabilities to whatever customer you're working with, or if you're managing a design team and you want to be able to be certain that your team can prove that they've been able to internalize the skills that they've learned. These technical certificates are a perfect way to be able to not only celebrate them from a user standpoint, because you can print these up, post them on your cube wall, but you can also share these with your manager and help support the idea that you've gone through this content and you've really internalized the course material. In addition, we also provide certification prep. So if anyone's trying to pursue any of the industry recognized certifications, for example, SolidWorks has their CSWA, CSWE, and CSWP. That's a great way to be able to identify if people on your team or you have hit a certain minimum level of proficiency and kind of share that. Same thing on the Autodesk side. So we've got certification prep courses in there as well. So in addition to kind of the items that I talked about, a lot of what I talked about right now is very much applicable to specifically a team, or sorry, an individual user. There's also additional challenges that you might run into as a team. So individually, you might be needing to hit project deadlines that are part of your engineering organization's targets, internal targets. You might be implementing new tools and technology. You might be also just trying to keep up to speed with understanding what the skills and capabilities are of your users. These are all different capabilities that are part of the SolidProfessor platform as well. So some additional tools to be able to get insights into what's happening with your team. One last quick slide here. I'm going to be sharing as I get into the platform a quick overview of just the course material, and I'm going to talk about it from kind of the two different ways that we like to talk about SolidProfessor. One way is how to use SolidProfessor as an ongoing learning resource for kind of a self-directed learner, someone that wants to improve their own skills. Then the other part of it is managing the skills of your team. So there's tools inside of SolidProfessor that are very much focused on understanding and tracking the learning progress of someone who's managing a design team. And here's just kind of a quick overview of what that looks like. So we'll dig into that more when we get into the product demonstration. And a little bit more about SolidProfessor. So as I mentioned, keeping up to speed with all these different design tools is a challenge, and we're proud to count a number of very recognized corporations across different industries, whether it's aerospace, defense, energy, that rely on SolidProfessor to be the tool that's keeping them up to speed with the capabilities that their organization uses. So let me switch my screens here, and we'll take a look at the SolidProfessor platform, and I will try to share some lessons here as well. Let me get switched over. All right. So everybody should see my screen here. This is the SolidProfessor homepage. And just to see it live, so in the slide deck, I showed a little bit about the depth of the course material inside the SolidProfessor library. So everyone from TPM 1 who is getting on board with the new subscription, this is kind of a nice glimpse of some of the capabilities you'll have available to you. So if I go to this courses library on the upper left, I can take a look at a real nice high-level view of all the content that's in the SolidProfessor library that's available. And as I mentioned before, I'm going to kind of talk through two different ways we think about learning from the SolidProfessor standpoint. One is you should always have the SolidProfessor as a learning reference available to your users. It's kind of a independent learner, someone that's self-directed. And I'm going to walk through that kind of from a user experience first. And then what I'll do is I'll switch over and we'll take a look at the different tools and technology that's available for someone who's managing a design team. So how do you get insights into the skills level of your team members? How do you assign content and track progress? How do you really manage that skills development if you're managing a larger organization of users? So from an individual learner standpoint, there's a couple different ways that we can use SolidProfessor. One of them is if you're trying to pursue a certain learning objective. So in this case, a couple of the examples that we have is these learning paths. So especially if you're a SolidWorks user, pursuing your SolidWorks certified associate or your certified SolidWorks professional or expert, these are industry recognized certifications. And these aren't easy tests, but these are ways to be able to certify that you've been able to develop a set of skills up to a certain level of proficiency. You get a certificate from SolidWorks. You also become listed on the SolidWorks website as a certified user. And it's a very nice badge to know that you're using the software at a certain skill level. And what these learning paths allow you to do is to pursue these outcomes, because it's not just about what you learn, but how do you prepare to take the test. So as I click into this learning path, you'll kind of see a high level of what this learning path is about. It's about learning the fundamentals necessary for taking the test. I can see how long this course is going to take. So in this case, this is 11 hours of content. So this is a significant amount of learning material taking you from the fundamentals through preparing for the test. And so you can see I'll start with this first section here. And as I complete each one of these different subsections, I'll see some progress indicated here with this circle kind of filling in. And basically what I'll do is I'll start from the very top, work my way to the very end. And then as I mentioned, the certification test is not a gimme. So once you've gone through all the foundational course material that's necessary to learn, we also have this certification prep course. And I always kind of liken this certification prep to, it's similar to like an SAT prep, where it's not just about what you know, but it's about how to make sure that you're going to be successful taking the test. So things like, what is the test interface going to look like? What kind of questions should I expect? How should I budget my time? And if you're going to take the time to prepare for this test, how do you make sure you're going to maximize your test opportunity? And people that get through the SolidProfessor certification prep here have a significantly higher pass rate with the certification versus those that do not go through the SolidProfessor certification prep. That's one example of the learning paths. And again, this is kind of this first way of enabling users to pursue their own learning goals. We also have other topics here specific to learning GD&T techniques, becoming a 3D printing specialist, and then also one here focused on simulation. So let me switch back to the library and we'll do a quick review of some of the other course material that's available in here, and then I'll dig into the course library and highlight some of the other learning capabilities that are specific to an individual looking to enhance their own skills. So on the CAD side of things, we cover SolidWorks, Inventor, AutoCAD. Obviously, those can be used very much on the mechanical side. Revit, SketchUp, Civil 3D for those that have any kind of a need outside of manufacturing. We also have a great course here on engineering graphics and spatial visualization. So interestingly enough, a lot of the feedback we get from the organizations we work with, that a lot of students will graduate being able to design really fancy CAD models, but engineering graphics is something that is not heavily taught in schools anymore. And so we want to fill in that gap. So our engineering graphics course here talks about the fundamentals of creating 3D drawings. What is an auxiliary view? What is a bill of materials? Why would you create an auxiliary view? Why would you create a bill of materials, etc.? So very much foundational, but it's something that you can send someone through, as I mentioned, in the engineering to prove that they've passed all of the different kind of competencies needed, foundational competencies, and then also earn a technical certificate. So this is kind of that badge. So if this is a topic, an area of importance, a lot of companies do focus on engineering drawings still. This is a great course to send people through. Another good one in this category, navigate back here, is our spatial visualization course. And it's actually been proven that the ability to visualize and have spatial visualization skills is foundational to people to be successful in engineering. And this is, again, kind of rudimentary, I would say, but it's a great way to test your own skills and be able to develop these skills. And it's been proven also that the ability to build spatial visualization skills exists. So it's an important skill to have, and this course is going to help people to build those capabilities. Scrolling through the library, we also cover GD&T, something also very fundamental to engineering, and especially engineering documentation. Some more CAD tools. Again, we cover Mastercam, FEA. So this FEA course is not just about not about the software, but rather about the fundamentals of FEA. So understanding the finite element method. And for a lot of organizations that employ the finite or simulation as part of their design process, it's important to understand the concepts of the finite element method so that you can apply the software correctly. We've got a number of courses in here that really focuses on those foundational principles, the math, the theory, understand what's happening. And then we've got some other great courses in here, Design for Manufacturing. Again, going back to experience versus just learning from school. A lot of people can create pretty CAD models, but how do you think about design from a manufacturing standpoint? And so this course really goes into how do you think about that. So you're not creating just pretty models, but you're creating things that are manufacturable and that take into account mechanical or manufacturing principles. We also have a design for additive course. So Additive manufacturing obviously has been a game changer, but how do you rethink design from the standpoint of, okay, I'm not hindered by the same manufacturing limitations maybe now. So how do I rethink design? How do I understand the capabilities and how that applies to my design process? And then finally, kind of rounding out the library here, I mentioned CamWorks for anyone that's using CamWorks. 3D printing, so this is kind of understanding the concepts of 3D printing for anyone that's implemented 3D printing as part of their engineering process, either for prototyping or maybe for light production. ANSYS, MATLAB, and some other topics in here as well. So with that, let me dive into the SolidWorks section here, since I think that's really our main focus. And I'll share and highlight some of the areas of SolidProfessor that's going to help your team from a SolidWorks standpoint. So we cover all of the topics in SolidWorks from the fundamentals all the way through advanced capabilities. We also have an ongoing series here where, as I mentioned, it's not just about what you've learned, but how do you keep your skills sharp. So this is a 3D model mayhem. These are some challenges that are released on a bi-weekly basis. It's just a fun way to pull your team together and challenge everybody. Maybe do this on a weekly basis, maybe on a bi-weekly basis, and if people are getting through and they're passing each one of the Model Mayhem challenges, maybe there's a Amazon gift card for those people who do pass the test. So something to keep the camaraderie level up and throw some challenges around inside of the team. Let me go back. So going through kind of the library here. So we've got the beginner through certification. So this is kind of related to the CSWA. We've got introduction to SolidWorks, essentials for part design. I can just keep scrolling here. So advanced sketching techniques, advanced part design, advanced assembly design, certification prep. Anyone who's managing a design team, so you're sharing files and it's important to make sure people are following good housekeeping principles. It's going to make it a whole lot easier for someone that's picking up a part file that you've worked on if you've approached things from kind of the similar perspective. This is one of my favorite courses here, the Sufficient Modeling Design Intent, because it really does focus on those good housekeeping principles. So some of these might feel like basics, but if everyone's following the same principles, it makes everyone's life better. It's a whole lot less of, I don't understand what this person did, I'm gonna have to recreate their part. And it's also just understanding what someone did. So for example, getting started on your part, naming features, and how do you think about naming features? Thinking about function over form from a design standpoint. Consolidating noisy feature trees. I mean, this is just a host of really, really great lessons inside of this course that really makes a difference to someone who's operating and they're sharing files. Building some really good, like I said, good housekeeping principles. One of the things too is as I share these courses, this efficient modeling design intent, the way you would operate is if you wanted to go through the entire course, I could start at the very top, and I can just in a very linear fashion work my way down. One of the things I'd mentioned earlier from a SolidProfessor standpoint is we really believe on not only providing a resource for learning, but also for reference. And in some cases, you might want to come back in, not be using this as linear learning. Maybe you're just trying to refresh on some of these. You can see all of these lessons are typically very short, typically less than 6 minutes. This first lesson's 1.5 minutes, second one's 2.5 minutes, etc. And this allows you as a user to get to the course material that's relevant to you, and then skip those that maybe you feel comfortable with or maybe aren't relevant to you. In addition, if there's a lesson that's something you want to return to, that you want to keep at your fingertips, you have the ability to bookmark lessons, and I'll share this in a second, where you can go and see these quick reference selected lessons, so you're not going to be able to go back to them and find them very easily. And as far as from a learning standpoint, all these lessons are really well and good, and watching videos is a great way to get more of an interactive, multi-dimensional learning experience versus reading maybe tutorials. But the real learning happens when you download the part files and you work along with the instructor. And you can see down here, I've got exercise files that I can download. And these are the same lessons that are used in all of the videos. And so as a user, I can work along with the videos and really apply the principles of what being taught and really cement those by working through the exercise files directly. The technical certificates, just to highlight this too. So for example, the Sufficient Modeling and Design Intent course, I have a technical certificate available. As I get to the end of this course, working my way through it from the top to bottom, I can take the test. And if I score an 80% or greater, I'll earn the technical certificate, and this will become available to you in your achievement section inside of SolidProfessor for your account. So I'll keep scrolling here so we can take a look at some of the titles. We cover surfacing. There's different weldments, sheet metal, mold tools. You know, the list goes on and on. We have different case studies to be able to put those features that you've learned into practice. As well as a really important one here is anyone that's keeping up to speed with the new releases of SolidWorks, because they do provide a huge amount of new capabilities with every release. The challenge is always, well, how do I make sure that I'm implementing some of these new capabilities? The whole point of taking the time from an IT standpoint and also just from a time standpoint is because you want to take advantage of these new capabilities. We have an update training course, and you can see this goes back previous versions all the way to 2007. So if you haven't stayed caught up with any of the releases, here's a few hours or maybe a couple days worth of update material that you can go through. And all these these are all organized in a way to be able to get through and apply them to whatever you might be working on. So in this case, we've got a parts and features section, assemblies, and you can go through and focus your energy on the capabilities that might make a difference in your organization. And I always challenge people, you know, every year there's going to be one or two things in here that's either going to be, you know, let's say a handful of things that are either going to make your life better as a user, something that was in a drop down, now it's a right click away, or maybe there's a new feature or capability that's going to save you a tremendous amount of time because it used to be a very manual process. Finding those and implementing them with your organization can make a significant difference, especially over multiple years. And that's what these updates are for. So definitely encourage you to take the time, find these that apply to you, and make sure people are learning them. And so one of the areas that SolidProfessor is also, I think, important from a design team standpoint, and how do you maintain a design team skills, is how do you provide answers to people on your team or for yourself as you're working through your normal day. And as I mentioned before, one of the core competencies of SolidProfessor is the ability to find answers fast. So, you know, what do people do now? A lot of people might tap the person on the shoulder next to them. Or maybe you go to YouTube and you burn half of the time that you wanted to spend learning about or trying to find a lesson that's relevant to you. And it's easy to get distracted on YouTube, or it's difficult to know, well, what is the skill level and competency of the person that's created this video. In SolidProfessor, we really believe that ability to find answers fast is a key part of our solution. So I can go up to the middle here, and I've got my search bar, and I'm assuming I'm running through an assembly, and I ran into some 8 errors. Well, how do I go about finding an answer to my issue? So when I do a search, I can filter my results to SolidWorks course material. And here I can start taking a look at what are some of the different lessons that might help me through the situation that I'm in. So here I can see there's a lesson on assembly mate errors and troubleshooting mates. So I can see kind of a breadcrumbs Here's on the mate expert, repairing mate errors. And I can just click through and get directly to the lesson that might help me through the challenge that I'm working on. And I was going to try and share this video, but I think, I'm not sure if I'm set up to stream the audio directly.
It won't actually stream the audio, Tony.
It will? All right, so can I
It
try?
won't.
What's that?
It won't listen to your system audio.
It will not? Okay.
It will not.
All right, well, I encourage everyone, so maybe a quick note for those of you that want to get some exposure to SolidProfessor and just watch some of the lessons. And the reason I like to share them is because that's where the aha moment is. Oh, that's a great tip, or wow, I didn't know that. That's where really things come alive from the standpoint of recognizing that, all right, there's some things to be learned. If you go to the SolidProfessor website, for those of you that haven't already gotten on board with your TPM1 Premier or TPM1 subscription and have access to SolidProfessor, you can go to the SolidProfessor website. In the first 5 lessons for every single course are free. You don't need to register. You don't need to do anything. You can just go to this library dropdown, go to solidprofessor.com, go to library dropdown, and any of these courses, the first 5 lessons are always available to view, and that'll kind of give you a sense of the learning experience, what the videos are like, the professional quality, and the effort we put into creating these videos. So definitely encourage you to go to the website and click on a couple of videos. So, so really what I've gone through here is just kind of how do you use SolidProfessor as a user, right? So there's a broad library of course material in here, but how do you think about it from a learning standpoint? So we've got learning paths in here. You can do quick search. You can go through the list of all the different topics and browse the courses that you need. But part of this session is about, well, how do I manage the skills development of my team? One of them is obviously self-directed users, making the tools and resources available. The other part of it is inside of SolidProfessor is really creating a managed learning environment. And how do you kind of cater the learning experience and get insights into your team's skill levels, and then manage and improve that skills development of your team. In part of SolidProfessor, we have an enterprise solution. This is part of one of the subscription packages from TPM 1. And what I can do is I can actually go into this other area here. You'll see at the top of the screen, I've got groups and I've also got reporting. These are capabilities that are available to anyone that's an administrator of a team. And so these groups, these are something that can be created by an administrator. And if you've got certain learning objectives that you want to pursue, you can pull from the entire library of content and think of these groups as kind of a learning outcome. So in this case, I've got a couple different examples here. I've got the CSWA group. And so maybe you've got a group of users that you want to run through the CSWA and have them take the test. This is a way to be able to collect all the appropriate course material together, add users into these groups. And what you can do is you can actually track progress of users. You can assess skill levels. You can see how people are making it through the content. Another example here is we've worked with Google. Google has a new Googlers process where anyone that's new to Google inside the engineering team, they have to go through a set of course material that's required for new users before they give them access to the software. You might have sheet metal users where there might be SolidWorks fundamentals. And so this is a way for you to be able to cater the course material together, depending on how you want to have it and how you want to set it up. And there's a lot of flexibility here, and run people through the course material. So let me show an example of how that works. So if I wanted to create a new group, what I can do is I can choose from a full lesson plan. So this is from a full content or full course inside the library. Or I can also pick and pull from associated lessons from any of the courses in here. And so depending on what your what your objective is, you can choose either one of these. And an example that might be interesting for this start from scratch one, if you want to pick individual lessons from any of these courses, Maybe there's a new user onboarding series that you'd like to have your new users go through some fundamentals of SolidWorks, and you want to test their skills on that. You also want to run them through a little bit of GD&T that's really core to how that's important to your organization. Maybe there's 3D printing in there as well because you have access to 3D printers, and maybe there's a little bit of engineering graphics because you want to make sure people are comfortable with using creating 3D drawings. And you can actually pick and pull each of those lessons and create your own custom course using this other one right here. This also includes some skills assessment as well. I'm gonna, for this example, just click this use lesson plan. And I'm gonna call this one TPM manufacturing. Make sure I spell it right. And I'm just picking that as a name. So let's just pick for this TPM manufacturing. Maybe I want to pick from these SolidWorks category. And this is going to be an introduction to. So maybe I've got some new users. Let's actually let's do this essentials for part design course. This goes deeper into part design. And what I can do then, once I've selected this category of content, you can see what it does is the platform is going to break these down into different categories of learning. So this course is broken down into Introduction to SolidWorks, into Introduction to Sketching, Understanding Sketch Tools, Sketched Features, Applied Features, etc. So these are very logical ways to break up the course material and the content. You can see I also have the runtime for each one of these different sections, so you have an idea of what's the total the total course time that you're asking for your users to go through. And now this is where we really start getting some of the real power of SolidProfessor in managing and assessing a team's skill level on all these different capabilities. I have the ability to select this include baseline test. And so what this will do is before a user goes through any of this course, they'll be asked to take a short test. And this test is valuable to both the user and the administrator because what it does is it's going to pull from a question bank of questions associated with each of these different topics in here. And depending on how someone scores on any of these questions, if someone misses a question associated with any of these topics, you'll see in the curriculum and a finger, an icon will highlight next to the lesson, indicating that the person who had taken the test missed a question associated with this lesson. So it's kind of a, hey, pay attention to this lesson. You missed a question here. This is valuable information that you missed. And then from an administrator standpoint, in the background, you'll also get a sense, you'll also get the test scores, and you'll see how well people scored. And as part of the learning process, someone will go through the baseline test first, you'll run through the course material, and then there's a final test. And you'll see in the final test versus the baseline test, the actual measurable skills improvement of that individual. I can also control the number of times the test is taken here, so I've got the option. And then also some player controls here. So in this example, I've decided I do want a baseline test. You don't have to put a baseline test if you don't want to, but this is just a way to be able to assess those user skill levels on any of the topics that are in here, or for any of the topics in the SolidProfessor library for that matter. So I'll complete this lesson plan. This is exactly what your users will see. You'll see each of these broken down subsections, and I can switch this from a grid view to a list view. Users will see how well they did the baseline test, how well they're progressing through the course material. If I want to, I can also establish a due date, and then they'll be able to see as they're progressing through the course material. Excuse me. Associated with that is, well, how do you get insights into what's happening with that team? So I've got an entire reporting section, and maybe I'm gonna just verbally share this, but with these groups, the next step would be after I created this TPM manufacturing, I'll share this in a second, but I can drop users into that group and they'll be able to log in and see what I just shared with you. But insights into what's happening, this is also a key part of managing a team, especially if you've got a globally distributed team or nationally distributed or just a distributed team. in general. Well, how do you understand what the team is doing and how they're engaging with the learning material? So at a high level, I can just pick the range that I'm interested in here, and I can get an idea of, all right, what's the engagement that my team is having with the learning materials I've made available to them. So in this case, I can see total number of lesson views. I can see if people are searching SolidProfessor. Again, this is key because you want people to use the resources and you want to find answers when they're running into challenges that they're going through their workday, or they're using SolidProfessor as a reference, as well as test questions. You can also get in different insights, and I've got, this is my Dunder Mifflin demo account here. I can see how well, who's the most engaged members of my team, who's going in and watching the most lessons. So Jim Halpert here is kind of the go-getter. Oscar's doing great. Pam's spending some time. So I just get some high-level view of what's happening with my team. You can also see what's the most engaged with content, who's spending the most time in what courses. Going back to those groups, so this is kind of a high-level view of the course material. If I take a look at these groups here, I will look for an example. So I created the TPM one, but I did not drop users in. So I'll look for an example where there are some users, so we can look at some of the data. So I have an introduction to SolidWorks group here. These are the users that have been dropped into this course. And I can see a high level progress of, okay, so Pam is at 15% progress through this entire course that she's been assigned. Toby 7%, 12%, 32%, kind of respectively. And then through each subsection, I can see assignment progress. So it looks like everyone except for Michael made 0 progress, but everyone's making through the first section of the content, and they're progressing, and they're making their way through it. I can also see how well people are testing as they get through this. So I can see how Toby, he seems to be leading the pack, tied with Dwight. Both of them got an 86% on this first review test in the first section. And this will continue to populate as users get through that course or that group that's been assigned to them. So this is kind of the way from a administrator standpoint, you really get to manage that skills development in your team. And the idea here is I want to make my team better by the end of this year. And these are the tools that help you get some insights that, yeah, you achieved that, you made that kind of progress. I can also download all of this, the groups to an Excel spreadsheet here if I want to get a high level sense of what's going on. A lot of companies we work with, maybe they'll have some fun with this. Maybe there'll be a certification goal, and I'll download and show off how well people are doing along the way. And maybe people that get a minimum 80% will do a Amazon gift card, or maybe there's a pizza party for those that made it through the first week and they got a minimum score. Have some fun with the learning and make this important, because the end result is it's going to make a big difference for how the team operates and how everyone interacts with each other. So have some fun with it and use these as ways to be able to create some visibility with your team as well. Some other examples too. So we've got an update training assignment here. If maybe you handpicked the 5 lessons that you know are going to be important to your team, you can create an assignment specifically with those lessons and have your team go through it and get a sense of how well people are picking up those capabilities. One other item, a couple of things I'll highlight here as well. And so I'm clicked on the top to this dashboard screen. Before, as a user, I clicked the bookmark button and I bookmarked some lessons. So this is exactly where your bookmarks will show up, so I can go back to these at any time. I can also see the history of any lessons I've looked at. So if I want to, maybe there's a lesson I reviewed recently that I want to get back to, I couldn't remember what it was, but I can get back to and say, oh, there it is. I want to make sure I review that. There's 30 seconds in here that really changed my life, but I forgot. So some good reference tools. Also an important item to highlight here is we have a SolidWorks add-in. So this is something that will make SolidProfessor show up right inside of the SolidWorks task pane. And this really supports the idea of providing and having a reference tool and a learning tool right at your fingertips. So what you can do is you can download it from right here, this link, go to the tools add-ins inside of SolidWorks, and you'll see SolidProfessor right there inside of your SolidWorks interface. You have learning right at your fingertips. So with that, I don't know if we're taking time for any kind of questions. We got about 10 minutes left in the session. I think maybe we're just doing a presentation, but if we are taking time for questions, I'd be happy to answer any. If you have any questions, feel free to type them into the chat. And since we got a couple minutes here, I'll just highlight the, still need to activate my SolidWorks. I was gonna share the add-in inside of SolidWorks. I don't have the fastest machine here for this SolidWorks install. All right, so just to highlight, so I've got SolidWorks running here. Normally I should have a really cool looking part file on screen, which I don't. I've got my latest home project. That's the best I get to do with SolidWorks these days. But here you can see, here's the add-in inside of SolidWorks. So you really have SolidProfessor at your fingertips and learning at your fingertips. So I can follow any of the learning paths. I can get to my bookmarks. My bookmarks down here. And then I've got my ability to find answers. So if I do a search for mate error, I'll be able to see those same results that I saw right here inside of SolidProfessor going through a web browser. I can refine my search. So I'm looking just for the SolidWorks material. That is not what I expected. Oh, I think I lost my. So there we go. So there are the lessons that I saw in my other search, and this puts SolidProfessor right at your fingertips. So again, if anyone has any questions, feel free to tap them in and type them into the chat box. And otherwise, I was gonna just wrap it up with some information. So if anyone has any kind of questions for me, leave some presentation. Leave some contact information. And again, I just wanted to highlight we're excited to be partnering with TPM, being part of the TPM1 subscription package. And if anyone has any kind of specific questions, again, feel free to chat them in or email me. And beyond that, I'll pass it back to you. Alex, I think you're doing the
We're
MC.
good to go.
All right.
And if anybody missed any of the earlier sessions, these have been recorded, so we will be posting these in a couple of days.
Fantastic.
All right, well, thank you, Tony. Our last session today is going to start in about 1 hour and 10 minutes, guys. So we'll kick back off at about 1:30 or so, and we'll finish up our sessions for today. Thank you all.
Okay. Good afternoon, everybody. My name is David Kramer. I'm with a company called Levitech, and I'll be talking to you today about keeping your PDM, your PLM data in sync with ERP. Little background on me, I've been in this space for about 20 years. I've designed over 600 migrations, and not quite as many integrations, but quite a few integrations as well, which is kind of what this topic is about. I've been working with CAD, PDM, PLM, and if you go back far enough, virtual reality, and a strong background in software development as well. My role here is just to kind of educate our customers and our partners about our capabilities. And also, I really like to help people understand the space they're in. So a little bit about Levitech. We are system agnostic. We work with virtually a lot. I can't say all, but a lot of CAD, PDM, and PLM systems. We have 4 offerings: migrations, integrations, advanced implementations, and customizations. We're located over here in Seattle, in Spokane, and we have an office in Pune, India as well. We carry quite a bit of expertise in the SolidWorks domain with PDM Professional, Managed, 3D Experience, and then in other domains as well. And that's a little repetitive there. So I'm going to go ahead and skip this slide. If you've made it onto this into the GoToMeeting, you're doing a lot better than I am, because I struggled with it. So thanks for everyone's patience and hanging out with me while I got running. So just to level set, because PDM, PLM, ERP data could mean a lot of things to different users, to different people in the audience. So when I say this PDM, PLM, ERP data, in the PDM and PLM space, I'm talking about your CAD parts, assemblies, and drawings, your non-CAD documents. If you're a PLM user, you have items or parts, you have many types of BOMs. You might be representing the CAD BOM in PDM. You might be representing an EBOM in PLM, and even in multiple MBOM views with routing and all sorts of other information, alternate BOM views, etc., within your BOM capabilities, your PLM system. And you're also managing a lot of viewables, and that's kind of important too, just because those are going to be needed sometimes by your ERP system. Your ERP system has items and BOMs, and it does a lot of other things, but these are the data that I'm referring to when I say keep it in sync. And it's really common to have some shop floor viewables there, PDFs, step files, things that you will need outside of the PLM system. And then there's this concept of what's called tombstone data, or metadata, the information that everybody needs in order to keep things in sync. So that's your number, your part number, your revision, life cycle statuses between the different systems. Sometimes descriptions are really important. And then from your BOMs, you want to make sure your unit of measure, your quantity, and then after that, plus more means there could be a lot of other things that it may end up wanting to keep in sync between all these different systems. So why bother to keep it in sync? Why is this something that you may want to invest in? Why is this something other companies are doing? This is kind of what this is about. Number one, let's try to get down to a single point of entry. We don't want to create the BOM in SolidWorks and then have to tweak it a little bit in our PDM/PLM system, and then have to go and repeat that entire process in the ERP system. That's just a really error-prone process, and I think even more than that is frustrating process. Nobody really likes doing the same thing twice. These data entry, this can lead to data entry errors, which can cause you to scrap supplies in the future, to carry inventory that you don't need, and so basically it causes your ERP system to be used incorrectly. It could have faulty data in it. And then it also might feed back to you. You might have to rework your design because of a variety of reasons, from just data entry issues. The other thing is it's nice to have the same BOM in all your locations. It's nice to have the same item master in both locations. That way you can find things, you can cross-reference things, and you can create what's called a digital thread, which a year ago was the topic that I did. So it kind of covers the main benefits here. They seem small at first, but they're the kind of thing that make you feel like you're running in water versus running, just on a track without the water. So they can really just kind of produce constant business drag in everything you do in your business processes. So if this is something you're interested in, how would you get started in this? And this is just kind of a preview to our process. I'm going to go through each of these bullet points in a little more detail. The first thing that's really important is to start looking at what's the center of your data universe. I've thought I was clever and called it Dataverse. And I'll talk to you more about what that is. And then after that, you need to start, once you have that new, or if you're evolving your company a little bit and you are changing the center of your dataverse, then what are your existing business processes, and how do you need to redesign those to leverage the new integration capabilities, the new automation you're getting, and maybe this entirely new way of managing documents and items that you weren't really leveraging before because of all of the data entry you're required to do. So once you've gone through, that's a scoping process, that's a design process, that's really preparation work, those first 2 bullet points. The next 2 bullet points are really the work. Next, you want to get your item master in sync between your PDM system or your PLM system and your ERP system. Otherwise, there's mesh points, like think of gears. You want those gears to have the same gear ratio, so that way they're in sync. If you don't do that, then there's constant binding of your 2 systems, and the user has to go in there, unclog the system, and then it starts to spin again. So you want to get those in sync, and then you want to keep it in sync. So as new products get introduced or as existing products get changed, these are critical events that you want to monitor and make sure that your item master stays in sync. And that's kind of what brings us to the goal that you're trying to have. So I said earlier, define the center of your dataverse. Let me just kind of expand on what that means. There's kind of two ways you could look at it. You could be item centric, and that typically promotes a top-down design approach, or you could be document centric, which is kind of a bottom up. And so in one way, and when I say document centric, that usually means your data is generated from your CAD designs first, your CAD designs push data into your ERP system, etc. There's nothing wrong with either one of these approaches. It's just good to understand which approach you want to use and stick with it throughout your design of your integration. Because if you don't have this clarified, you will make decisions that contradict each other later on after you've started testing. You're gonna be like, this isn't working, and you're gonna wonder why, and it's because you didn't pick one approach. So just to elaborate on this a little bit more, so with an item-centric approach, a way of looking at this is when the PLM or ERP item, and I'm using double air quotes that you can't see, is released, the related CAD file is then released and locked. So you can see how, and you could also think about when the ERP item is created, then later on a CAD model is created, or later on a CAD model is associated with that item. So the item comes first. The item structure comes first, and that could be modeled in ERP through a configurator, that could be modeled in ERP just through tribal knowledge, or it could be done in PLM by reusing an existing structure, creating a new one. When that item goes under revision, then the related CAD models are also moved into a work in progress state. So the CAD always follows the item, and that's important from an integration standpoint if you're keeping things in sync. The workflow really is managed. Your complex workflow work is done in PLM or in ERP. So change management, all of those other things, they're managed in one of those 2 locations, and that's an item-centric approach. This is really this will require you to have a good integration between CAD, PLM, and ERP. So that's kind of drives that. A document-centric approach is the exact opposite. It's kind of when the CAD file is created, then a new item is introduced into ERP or PLM. It's really, usually document-centric approaches are when you're using PDM without PLM. So if you're a SolidWorks PDM professional customer and you're not using any PLM to manage that data, you probably have a document-centric approach, or maybe you've done something creative outside of that system. And then again, I'm not saying one's better than the other. I'm just saying that they're different solutions. So everything is driven when the CAD file is released, the ERP item status typically gets released, or that ERP BOM gets released, or maybe you have previous statuses in that PDM Pro workflow that cause you to go and update that BOM, and you're doing all that dual entry there. It's a push. So item-centrics tend to be bi-directional synchronizations. Document-centric are a little simpler to actually integrate because they seem to be they're typically a push from your PDM system out to ERP. So that's a kind of some thoughts on what that means. The next step here is to document your as-is business process, and I really should have put double like quotes around as is, and document and then design your to-be business processes. You need to go into this with the understanding that when you do this, it's a good planning exercise, but that's all it is. Don't get into analysis paralysis and try to work out every single detail. Your to-be business process is going to be an ongoing evolution. You don't need to get it perfect. You need to get it good, and then try to leverage the main benefits of keeping your data in sync, reducing human interaction, and creating machine readable content. So your data card in PDM Pro becomes really important as you're designing your to-be business processes. You might need certain pieces of information to be transferred back and forth. The two processes that we encounter the most, and there's different names for these, but the two most common ones are new product introduction or new part introduction, and then your change management. All of these, you might be thinking, well, what's our release management? Well, releases can occur within both of these processes, or maybe you just have a release management workflow and it's doing bits and pieces of these things anyways. So new product introduction controls where and how new things are created, and where will you, and it kind of defines how we're going to keep your new stuff in sync. Change management is how and where the change management workflow be governed. And so that is an interesting conversation, because if you implement manage, for example, you want to put your change management inside of management, or you want to put your workflow complexity inside of manage at the PLM level and make your PDM workflows really, really simple. So that way the integration works better. And that's true for almost all of your integration types out there. It's really nice to have those. You don't want those workflows spanning all your systems that you're keeping in sync. So put it in ERP, put it in PDM, put it in PLM, and have minimal touches outside of those systems, because that's where you get that dual entry issue. Getting the item master in sync. This is something that is very frequently overlooked when planning on an integration. And to be clear, when I say keep the stuff in sync, I'm talking about integration software. I'm talking about doing something you don't have today. You can do this manually, but you probably already are, and it's already painful. We're talking about replacing your manual processes with automation. A lot of people forget that you really want to get that item master in sync so those gears stay in sync with one another throughout the life of your processes. So you want a clean item master that's very consistent in both locations. So if you have part number 1, 2, 3, 4 in PDM Pro, you would also have part number 1, 2, 3, 4 over there in ERP. And you can make clear correlations on those. Now, that gets complicated when you have a SolidWorks part number or configuration number, actually, that is represented as a purchased item or something as a specific item in ERP. So you gotta take that into consideration, your configurations versus the file number, all that. This can, if you don't get your item master in sync, you could stress your integration system on startup, because they're not bulk migration solutions. These are typically piecemeal, bit by bit updates, and you could really stress that integration and it won't perform very well when you kick it off, because everything's out of sync. People are going in there manually doing data cleansing, and your entire team is frustrated that the integration really didn't bring the benefits you were hoping to right out of the gate. It required way more data cleansing than you were expecting. Then we start, once we get that item master in sync, also making sure we don't have duplicate items between the two systems. We do a gap analysis. You're looking for duplicates and missing items, and you're taking care of that in advance. And that usually leads to really good conversation over, oh, we did create this, but I used the -A on that number for some reason, and you start figuring those out and cleaning up those numbers. Or you create a new number altogether, and there's various ways you do that. So that's that cleansing. And when I say cleanse and standardize the data, that's where you go and you're fixing all those issues. But it's good to have software that can help with that process, because if you have a large item master, doing that one by one is not a fun process. So the outcome of this is that it's good to have a solution that can migrate your items and BOMs and your visualization files or viewables between these two systems right before you even go live. So that way, when you turn on your integration or your synchronization, you're up and running with a really good system. So then the final step here, or the next step, is to keep it in sync. So that requires software. So at this point, we've analyzed, you've analyzed your business processes. You've decided here's how we want to do it, and you've configured some form of integration to essentially do these two tasks that are listed out here: create/update items /bombs in PDM/PM. So basically, when you multiply all these out, it's like 1, 2, 3, 4, 5, 6. So it's like 36 different combinations of updates and creativity things, creation actions that you'll be configuring in the integration. You may also come and say, this is great, but now that we're talking, I don't want to have to go to my ERP system to look up a part number. I just want to stay in PDM Pro and do it. So some customers may say, okay, let's go ahead and implement new search functionality. Let's do a part number lookup. Let's be able to generate a part number from system X out of system Y, so we're not logging in and out of all these different systems. And then we want to propagate our viewables, our PDFs, our step files into our ERP system. This is the most common direction, of course. So that way we can share it with other suppliers, customers, or with our shop floor. So those are real common requests of keeping data in sync. That's what you'll need, software that can do these things. All right, so this wasn't listed before there, and I debated whether or not we should get into this, but what could possibly go wrong with all these great solutions? It sounds really nice. So what's the catch? The catch is these systems aren't stable. Your PDM system may go offline because it's rebooting, for example, or the server is down for maintenance. When that happens, that doesn't mean that your ERP system's down for maintenance, and it could be that your ERP system's generating new content. All of these, there's keeping things in sync requires all of those systems to be operational. So you need a real robust recovery system that can capture when one system's down, it can continue to capture what's happening in the other systems. That way, when both systems become live again, you go ahead and resynchronize everything. You want reliability for years to come. So this is where a traditional thought is, I'm going to go out and buy a piece of integration software, and it's going to do this for me, and it's a one-time purchase. Well, that means that in that snapshot in time for that system you have today, you just got something that works today. But you need maintenance on that. You need ongoing support, because integrations are much more. Instead of thinking that you're buying a rock, think that you're buying a living thing that needs to be fed, maintained, taken care of. Integrations are like that. Your business processes are changing constantly. Your data is changing constantly. The people involved with these, there's turnover within companies. There's turnover within underlying technologies. So you really want a piece of software, an integration platform that can survive change, both internally and externally to your company. And you want that flexibility to reconfigure and change your mind. One thing I've always said with what we do at Levitech, we allow engineers to change their minds. You like PDM Pro today, maybe you want Manage tomorrow. You like Smart Team yesterday, and now you want to be in PDM Pro. You want to be in PDM Pro today, now you want to be in 3D Experience Works tomorrow. All of that, it requires change. It requires lifting and moving and loading and all sorts of fun things. So that's kind of what we are here for. We're here to help with that. So I usually say, okay, does anyone have any questions? And what I found that these are the most common questions. And then at the end of this, we can open it up maybe to some Q&A. But the most common questions is, should we integrate our CAD system directly to our ERP system? Should we integrate our PDM, let's say PDM Pro, to our ERP system? Or should we integrate, let's say you have a non-managed based system, you have some other PLM system to ERP? My answer is, it really depends on this question. It really depends on where you are today with your BOMs. So do you add a lot of value to do you have to modify your BOMs quite a bit to get them into ERP? If you're coming from CAD, that's really, CAD direct to ERP, that fits with a very specific type of business model for the customer. In general though, I would always, if possible, if you had to choose between these three, I would say go try to do your integrations with the most advanced system you can from a BOM capability standpoint. So I would integrate with PLM to ERP, because your PLM system can manage so many different types of BOMs, even the manufacturing bill of materials. If you integrate with PLM, you gain the advantage of exposing the MBOM to the design engineer so they can make better decisions that might reduce manufacturing costs or give them some visibility in how this is being produced in different states and different countries. All of that would be capable. You'd have that capability within a good PLM system. PDM system would allow you to create you can typically get a nice EBOM and share that with your ERP system. But now your ERP users will typically still need to go and do some post-processing on that EBOM in order to add their manufacturing items to it. So you can see a little bit less value there, but it's still really good over manual processing. And you may not even need that extra step if your business processes don't require it. And then the last one, should we integrate with CAD to ERP? On this one, to me, it's kind of an interesting concept. It's not something that I think a lot of companies do this. I think it is quite common. I think a lot of the companies do it because they don't understand the value of PDM though. And so hopefully I'm not stepping on anyone's toes on the call, but I would highly recommend, because a lot of companies will integrate with CAD to ERP and not do PDM, which just really risky. You don't have any CAD control. You don't have any version control. You're choosing to live in the Wild West in my mind. So I would say get in PDM and then do the integration. So that, just kind of preemptive Q&A here. Do you need a bi-directional integration or a one-way integration? Typically, if you're item centric, then you need a bi-directional integration. Your ERP system needs to push information over to PLM, and PLM needs to go and push information back to ERP. If you're document centric, usually one direction or one-way integration is good enough, although we have customers that do want to generate part numbers out of different systems, and so there's some bi-directional needs there, but it kind of comes down to which data model you choose or you need. Sometimes our customers have really unusual workflows, and that's actually, I'd say every customer has some type of unusual step in a workflow. And yeah, we can definitely handle that. There's not very many business processes anymore that we haven't seen. So virtually anything you can concoct, as long as, with one caveat, as long as there's a machine equivalent of it, we can automate it. However, what if you have certain steps in that process that there's no way a machine can do this? And by machine, I mean we have a rules-based engine or some type of program. Can this be programmed? These button clicks be programmed? There's some that there's just no way that this is impossible. This cannot be done. So then you want integration software that has a workflow of its own that allows you to automate certain parts of the business process, then to involve a human to make a decision, give a go, no-go decision, and then resume the process. So human in the loop integrations are common. They're nice because they isolate you out from data entry and put the person that we're involving in the loop into the decision-making process using their knowledge, their experience, and not relying on them to type on the keyboard and do something that is error-prone. So we can absolutely do that. The next one is, look, we'd love to have this integration, but our data is horrible. And really, when I said rough, that's probably a nice way of putting it. So internally, you might think of it as horrible, but we call it rough. Yeah, it's really common to see rough data, and you're going to have limited returns on that. But there is, from our standpoint, we've developed tremendous utilities to go in, clean up really rough data, and I'm talking data that's 60 years old, and go in there and clean up. Now, we can't manufacture data though. We can't go in and read a JPEG and determine that so-and-so drew this PDF or this image, that was scanned from paper 14 years ago. Can't do that. But if you have any metadata, but it's just inconsistent, we can definitely do that. We have gone through, we can scan PDFs, read data out of PDFs, AutoCAD, old legacy formats. We do a lot with APIs. We don't want to do that, but if there's value to it, we'll figure it out. Then some of you, maybe some more advanced users, are thinking, you know what? We keep our data in sync today using a some functionality in PDM Pro called the XML file drop or XML file export, and that's taking care of our needs. If that's taking care of your needs, then absolutely just keep on using that. So when do you want to move away or graduate out of what is a fairly standard, straightforward integration method, which is just exchanging XML files, to actually wanting to take that next step up and automating your integration a little bit more. The reason why you would move away from the XML file drop is you need some logic to help your business processes get done. You need human in the loop. You are tired of thinking that something was updated when in reality it wasn't. It is somewhat common for someone to use XML file drops to actually not act. It takes away the data entry, but it replaces it with data review, because you don't know if everything got updated correctly, and there's sometimes doubt that can be created. Now, if you have a real robust system, it's bulletproof. Don't change it unless you need more automation, you need more logic, you need there are, and if you have any questions like, hey, we've already got this working, but we have shortcomings, then you reach out. Maybe it's the right place to start for you, maybe it's not, and it's something that TPM, they can just go and configure that XML file drop for you, and your ERP system would have to come in and read it. We get involved when that's not good enough, and you need something more than that. And what if you decide to change? You know, if you want to change, that's where your point-to-point connectors, where you have a PDM Pro connector connected straight up to an SAP connector, that's a limitation of that style, because those connectors have to be configured to work with that specific ERP system and that specific business process you have. So our approach is to simply not rely on point-to-point connectors. We use middleware, and so you know, that hopefully gives you some ideas. And of course, I want to talk about us a little bit. I want to tell you how we're wonderful, and we're going to be able to help you out if this is interesting. If you were wanting to say, okay, I want to take the next step, we can help you out. We do free business process consulting. We have people that have worked in industry 14, 15 years and gone through pretty heavy business processes in their organizations, gone through the as is to be, the physio modeling, all sorts of things. We can help that. We include that with our scoping. We provide all of our middleware for free. So we really try to hit you with a lot of value. We have our middleware includes a rules engine, allows us to do extremely advanced workflow automation. We also specialize in data migrations, and data cleansing, which is the predecessor to doing an integration. For some people, you do need to go through and clean up your data, or even migrate your data from point A to, we've done migrations into ERP, we've done migrations from ERP back into PDM, just to create an item master that gets really well standardized, that we have a really clean meshing synchronization. We can involve humans, where we're just emailing them, you're clicking a button once you've made a decision, and that button is communicating back to our software and resuming processes that were temporarily put on hold while you made decisions. We have a lot of PDM, PLM, and ERP connectors. We don't have all. There's over 3,000 ERP systems out there, and a minimum of 10 PDM and PLM systems that we have to work with. So we don't cover all of them, but we have a developer network that we use for creating anything we don't have, and we already have some, you know, quite a bit. We can work on-prem and cloud-based systems, so there's no real limitation there. So I kind of blew through that. I've had maybe too much coffee today. I'd like to go ahead and take a deep breath and see if anybody would like to throw some questions at me. I don't know, Robbie, if that's the next step here. Maybe they're typed in to the chat window. I'm not sure.
Yeah, we're going ahead and we're fielding questions. As those come in, we'll just answer them here at the end. And this session is being recorded, so if you guys miss any of the other sessions, all of these have been recorded today. They will be posted after the conclusion of this session. They'll probably take about a day or two to edit, and then they'll be online on our TPM Solutions channel.